So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. Cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special, something specific, specific industries.
Aviation and aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
Awesome.
Awesome. Awesome.
That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning, now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in the breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skates out tonight. I'm gonna go out and have a good time. Ain't nothing gonna stop me tonight.
Welcome to Formnext News, coming to you directly from the Frankfurt exhibition grounds with the latest updates, insights, and innovations from the world's leading event for industrial 3D printing and next-generation additive manufacturing. Here are today's top stories from Formnext News, live from Frankfurt. We mark 10 years of innovation at Formnext 2025 and shine a spotlight on Spain, this year's partner country. We also bring you key takeaways from the AM Innovation and Standards Summit. Plus, stay tuned for the latest product announcements, technology showcases, and a preview of upcoming highlights across the show floor. Today, Formnext 2025 opens in Frankfurt, celebrating 10 years of additive manufacturing innovation. Since 2015, the fair has grown from 200 to over 800 exhibitors, welcoming 30,000 to 34,000 visitors annually from more than 30 nations, including Germany, USA, China, Spain, Italy, and France. With over 54,000 square meters of exhibition space, more than 149 talks and panels, and hundreds of speakers and innovation projects, Formnext remains the global hub for the AM industry. The next 4 days promise inspiring showcases, discussions, and networking. Welcome to the 10th anniversary of Formnext in Frankfurt.
Where ideas take shape is our claim, and that's exactly what it is. This is where people come together, where ideas are being shared and are launched, really. So you're most welcome to join us here this week in Frankfurt. Come and stop by.
On Monday, the AM Innovation and Standards Summit brought together senior representatives from government, industry, and international standards organizations. Hosted by the U.S. Commercial Service, ASTM International, ISO, and America Makes, the one-day event focused on the industrialization of additive manufacturing and the challenges of scaling adoption. Through keynotes, panels, and a workshop, participants explored sector-specific approaches, success stories, and hurdles in AM qualification and certification. Attendees gained insights into implementing ISO and ASTM standards and heard directly from the organizations shaping the global AM ecosystem. Spain is this year's partner country at Formnext, highlighting its growing role in additive manufacturing. Despite being a smaller market, Spain is expanding rapidly with double-digit annual growth. The sector now employs over 1,000 people, and machine sales and services have risen by 24.5% and 36.2%, according to AMIT. Supported by strong networks like AMIT and IAM 3D Hub, Spain is once again strongly represented here, with around 30 exhibitors. Additive manufacturing is rapidly transforming construction, architecture, and design. And Formnext 2025 highlights the latest breakthroughs. The BAM Special Exhibition showcases around 30 exhibits from research and industry, including 3D printed buildings, functional components, sustainable materials, and innovative furniture. Visitors can see landmark projects like Tor Alva, the world's tallest 3D printed structure, and Europe's largest 3D printed building, the Wave House, as well as modular and sustainable applications using mycelium, recycled plastics, and natural fibers. Formnext demonstrates not only what is technically possible, but also provides a platform for exchange between innovators and industry partners, showing the growing potential of additive manufacturing in construction and design. Germany-based EOS is strengthening its position in metal additive manufacturing with the introduction of 4 new industrial materials, shown here at Formnext 2025. The portfolio expansion is designed to support greater application diversity across aerospace, automotive, chemical processing, and marine sectors. Each material is fully compatible with EOS's laser powder bed fusion systems, enabling optimized part performance, more flexible production workflows, and improved supply chain resilience. With this release, EOS continues to drive the industrial-scale adoption of additive manufacturing worldwide. We wish you a successful fair day ahead in the Formnext arena. Don't miss today's sessions on the industry stage, including panel talks on perspectives, visions, and what's ahead in additive manufacturing. Plus the Pitch Next event for young innovators from 2:15 to 4 p.m. On the application stage, learn about AM applications in aerospace, medical and robotics, industrial, and energy and infrastructure sectors. And on the technology stage, discover key topics on workflow optimization, sustainable AM, data and process analysis, supply chain challenges, and solutions. Now let's celebrate Formnext 2025 together. Enjoy the breadth and diversity of additive manufacturing and the important role you play in this global AM community on the first day of the show.
Welcome to Formnext 2025. Welcome to our live stream here from Hall 11, booth D72. I'm very happy that you joined us in the live stream, and I'm very happy that you joined us here in our booth and our stage. And I'm very happy, Sven, that you are with me again. It's always good to have you by my side.
Yeah, hello also from my side to this wonderful occasion here on the industry stage, Formnext 2025. I'm super happy to guide you through the exciting program of the next days with my beloved partner in crime, Frank Jablonski. And talking about exciting program, Frank, what can we expect, or what can the audience expect?
Oh, we will have a rich program. Not only today, but until Friday, until the last day of the exhibition, we will have a rich program for you. We have various inside experts here on the stage. We will have panel discussions. Today, there will be a highlight for you this afternoon.
Yeah, I must admit, it's hard to mention the one highlight, but this afternoon we will have the startups here on stage with our Pitch Next event. That is, in my opinion, always a highlight at the industry stage, but not to mention the several other highlights we have, absolutely.
The Pitch Next will be my beloved part, because you are on stage and I will be in the audience, so that will be my great time. Over there is Formnext Awards, and I always, when I look there, I remember that we will have on Thursday our great award ceremony.
Absolutely.
You will host this one, and so that will be a very good time as well. But maybe, you know, we will ask the organizers and the management team about their favorites, and so give us a great welcome for the management team with Petra Harburger, President of Mesago.
For Sascha Wenzler, Vice President of Formnext.
And Christoph Stüker, Vice President of Formnext.
Big applause, ladies and gentlemen. Hi, Petra, good to see you. Sven, Sascha.
Good to see you.
Good to see you, Christoph. Hey.
Hi, good morning. Hey. Good to see you. Good to have you here.
Have a seat.
Thank you very much.
Yeah, it's so incredible that times run so fast. We are here again at the same place with a lot of smiling, happy faces. We saw our intro, and it's always such a good feeling. But Petra, we have a celebration this year. Normally I start with, you know, you are head of Mesago and you have a very busy exhibition time. You have to run the SPS, and that's normally my first question to get an impression of your mood, how you come here. But today I want to make it different. I want to hear about your first impression of Formnext. What was when did the idea begin to grow in you? When was the first moment you remember, okay, we are going to do something great?
Oh, I think, you know, it started long before the first Formnext really happened, but I still remember, maybe some people still remember as well, there was a different exhibition here in former times that happened. And during that exhibition, we had, it was like a task force, you know, we sort of ran around and then announced that we will take over the AM part of it. And it was really a little bit, I don't know. Do you remember? It was like something that we usually don't do, and it just sort of happened in the underground, you know, and then we just came on, and then it's so incredible to think about that. It's really 10 years now. It's so crazy, really.
And I think it's always worth to remember such times, but maybe a little bit coming off topic. I have a small task for you.
Oh.
What do you think? Which powerhouse, let's say, is built of 1.6 kilograms of butter, made around 60x, with 4 packs of fondant? Is there an impression? How many layers can build something? We have something prepared for you because, you know, it's not always everything about business. Sometimes you need time for celebration. So maybe maybe I talk a little bit about how important it is to have a good team.
Oh my goodness, look at that.
Who
A lot of muscles.
who are not able to run the camera and the live stream, but who are also capable of bringing a cake. So this cake is made of cinnamon gingerbread cream. There is one area made of black forest cream, and the third one made of cherry chocolate cream.
The bad thing is I don't know which one it is, right?
I don't know. We have to taste. Maybe we get a knife, or we have a knife.
And it's of course 3D printed.
Yeah, sure. Oh, how cool.
Petra, would you?
I think we do that together, Sasha.
Would you like to?
Christoph, come on. No,
together.
It's like, you know, the marriage. No, we don't marry each other now. Where do we start? Maybe there?
A little bit like a
Sven, maybe,
like a wedding.
Sven, maybe you help us with
I think that was the Black Forest cake.
chocolate.
Here we are.
Looks amazing.
It looks
Okay.
very
But
nice. I
maybe-
hand it over to
yeah.
you.
Oh, I get the
Maybe
first
we
one.
start at another one?
Great.
Let's go for this one.
Okay. If I would have known that, I wouldn't have had breakfast this
Oh,
morning.
that's enough calories for the next 4 days.
Yeah, definitely.
By the way, that's the advantage if you're in the audience at the opening session. Probably you get a piece as well. So,
Peter?
Thanks.
here we go.
It's a great idea, guys. How many pieces?
This is so nice.
Thank you.
And I think we just get it into our team office
Yeah,
later
that's
on, because I think the
that's
whole
the
team
idea.
That's the
created
low
it.
carb for
That's
me.
the idea behind.
That's
Yeah.
okay.
What we wanted to show that it's really 3D printed.
Great.
Layer by layer.
This is so cool. Yeah, layer by
Here we
layer.
go.
Let me.
Very cool.
Thank you very much.
It didn't take 10 years to build it up, right?
I'm not sure if it's a cake for a 10 years anniversary or from a 10 years. But never,
Thank you so much.
never
That
mind.
is such a nice idea. Thank you, thank you, thank you.
Yeah. Let's have a first.
Yeah.
Let's have a
first
first
bite.
taste. The first
Yeah.
bite.
Yeah.
I hope I didn't promise too much.
That's a good live stage appearance.
It's very tasty.
Absolutely.
And there's plenty to go around, so
So
Definitely Black
all
Forest.
the effort to lose weight just in front of the Formnext is being destroyed in 5 minutes. So it's
Believe me,
awesome.
Within the next 4 days, you get it off again.
You need a lot of
Don't worry.
energy, sugar, calories.
So Sasha did it the perfect way. So Sasha, let me step back into the celebration part and ask you a question. So,
Yeah.
like Peter, you're a person, or let's call it the first hour. Yeah. If you look back at so the first steps you had, how were the beginnings compared to today? I mean, 10 years later, they happen a lot, right?
The size, as you know and as you can see, is incredible. So we really achieved all together. So that's really a teamwork from our team, but also from the industry. and from all the attendees, the visitors coming, the press, everybody was involved the last 10 years, and it grew incredibly. So we really created together the heartbeat of additive manufacturing here in Frankfurt, and that's still amazing because all the global players, all the relevant companies, all the user industries, they gather here in November over the 4 days. It's amazing. So just to give you an imagination, it's 803 companies attending, 62% international ones this year. And we started in the very early beginnings when, like you asked, we started with a group of 7 dedicated companies. And these 7 companies created a kind of vision what's necessary for a growing industry, and you can see the result today. So, still incredible, but not to forget, it was also a journey coming out from a kind of little hype or second hype around additive manufacturing 10 years ago, and then it was a journey into very serious industrial manufacturing. And now we have a combination of industrial environment and very challenging economical and geopolitical times. So it's not an easy time for the companies, but it's an environment where everybody aimed for to be in this industrial field. And we just heard in the morning there are a lot of applications. Applications are growing, material variety is still growing, technology is growing, and now the economical framework needs a little bit of start the engine, but additive is a solution for this.
Absolutely. But I would like to hear about what milestones do you have in remembrance when you think about the 10 years, which you already mentioned one, the start with the 7 companies, but I think you are not so sure if it will work or if it will fit. So after 1 or 2 or 3 years, when did you get the feeling, the impression, oh, we really started something new, something great?
Yeah, the feeling came quite early. When we started with these 7 companies, that was in the very early beginning of 2015, and we had a kickoff event in a totally empty exhibition hall 3.1. And that's still in my memory, this huge empty hall. And it is very huge, 3.1. Yeah. And then from January until November, until the first edition, this vision grew to 203 companies. And we already filled around, let's say, 2/3 of this hall. And the imagination was quite like it is today. It was very professional, very nice and high standard stand constructions. So it looked already on a small scale very professional, having these very dedicated people on the stands and visiting. So this creation of additive addicts coming together, it was small, but it was already possible to feel it with the very first show. And also one of the moments always in my mind is that when we also organized the first Formnext party, which was
that's a good
the
one.
first impression. We thought, hey, let's organize a party.
These parties are always special.
But then the party itself grew to a special kind of event, and that's I think that's also very, very nice and unique.
So you always have you had a very lucky hand with choosing the band,
Absolutely, I can agree. Christoph, as me, you joined a little bit later the team, so we are. We're already in this phase where we found a new word that was in place, at least for me, and you could experience it was family. I think this is something you really, let's say, created, and it was not a buzzword, it was kind of a feeling. What were your feelings when joining and the development afterwards?
Yeah, I mean, I joined as the latest member of the original team, and that's quite an achievement as well. That all the original members of this Formnext team back in 2015 is still on board. We still have Anne, Anja, Heike is here around.
They are back on board,
Thomas
right?
back on board, yeah, and Thomas and the two of us. So that's also an achievement to keep this team together with this special spirit. And there was a bit like a startup within Messaro back in the day. So that was quite special. But I joined in April 2015, so as I said, the last one of the team. And it was a tough environment. I mean, we had loads of discussions, tough sales talks. It was really, really difficult. And then the first milestone, I would say, apart from the first edition, is then the 5 years.
Yeah.
And this year also we celebrate the anniversary, of course, with our special Formnext awards, glass awards. And back then we had to find a name for these awards.
Yeah.
And that was the birth minute. It was literally a minute. It was 5 minutes, I guess, where we defined the family topic. So we put this on the award, on the 5-year award, and then it grew from there. So
I
that
miss
was
the tattoos a lot.
that's a two, yeah. We have them as well.
Sorry.
You have no true tattoo?
No, absolutely
yet,
not.
not
Absolutely
yet.
not.
We have, but we don't.
We don't show it, right?
But yeah, from then, I mean, the team grew. So the growth in the industry is also reflected, of course, in our team in Formnext. I mean, this exhibition has to be looked after well. And we are now a team of, I think, 18 people dedicated to Formnext. So as I say, it's reflected also in the growth within our team.
Did the topics, did the content change in these 10 years? So were there minor or bigger changes?
Do you want to do the first part?
Yeah. Okay. Let's look back. Yeah. So when we described the first concept of Formnext as a trade fair, coming out of the heritage of a show already in place here, there was a combination of additive manufacturing and mold and die making on the exhibitor side of the show floor. So that was where we came from. That what was our start. But then, around 2 or 3 years, we recognized, hey, the mold and die companies, they are a perfect user group for additive. So this was a first major redesign of the concept, and finally it was the right one, because now we have 18, for us, we have identified 18 different user industries, and the mold and die industry is one of them, a very important one, but now it's joined by automotive, mechanical engineering, aerospace, medical, just to name a few.
Jewelry came this year.
Jewelry came this year, oil and gas, defense. So there are a lot more, and these are user industries for additive. So that was one of the first or the major change in the early days.
Mm-hmm. And Frank, if I may add, the topics I don't think have changed all that much, to be very honest, because we still have to talk about how additive is used effectively and sensibly, in which industries, in which use cases. So that's still a topic that's very relevant, even in this year. And I think maybe the focus has shifted a little bit from a technology-focused point of view to an application-driven and business-driven point of view. I think that's one major shift that we can see here as well, and that we would also like to, of course, support with the program that we built. But I think, again, the topics are still the same in a way, shifted ever so slightly. But yeah, overall.
Yeah. One special aspect of Formnext is that you cover the whole process chain.
Exactly.
So was it the idea from the first beginning, from the start?
Yeah. So that was indeed one or the first sentence I always used back then in the press conferences is, we will not organize another 3D printing show. We will organize an additive manufacturing event. And additive manufacturing was really still until today, or is still until today, the main principle. It's covering the whole processes of additive manufacturing over all materials, which is also very important. You have metal, polymers, ceramics, sand, glass, wood, so many materials. some more sophisticated, some still very experimental, but that was and is our core, to show the processes and an industrial solution for the customers. And still it is necessary to explain technology. So it's not about sales primarily going on. For sure, the companies want to sell their products and services.
Knowledge building and the transfer of knowledge.
Exactly.
Yeah.
So it's still educating the user of the technology how to use it on the right place, and creating what's very important now, a business case.
And I think it's really important what we see, and I think Rainer Lotz said that this morning when we had our press conference, is also for the exhibitors, for the people here, they also need to network and to connect, because they also create new ideas. So it's not only with the customers coming and the visitors, but also the whole industry needs the impulses from each other, especially due to the rather challenging overall situation that we just talked about. Yeah, so I think this is also about the network and building up the network, and that was also always our aim, to really build up the community and to try to be part of it. Maybe that's also a little bit this family thing, yeah? But I think that was also one of the success factors at the end. To be honest, the industry or the technology and the guys made us really easy for us, yeah, because they are really, really open-minded, very innovative. And I think this is something you can feel, and that helped us to create this community building and to really make, it's more than just this 4 days for us, yeah, it's really helping the industry, the technology to move forward and to really, find new applications, find new spots to I say also to grow and to glow somehow and to be more visible, yeah.
Christoph, Britta just mentioned collaboration, which is one of the major parts happening here. And this is what I experience over the time. And you said, you described the shift in a focus. And I think what I can feel, it's a lot determined this year about business focus and how to collaborate to stay in the business. How is that reflected in the program? Can you give us a short overview of what we can expect from Formnext 25 and how do we see the shift in the focus?
Yeah, I think, we have our 3 stages. So we have our stage for the technology stage for our exhibitors. So new technologies, new services will be on stage there. Then we have our application stage, which is just above us, and that's focused on applications within certain industries. So the 18 industries Sasha has already mentioned, we will have I think four talks on each industry, in order to show applications, show success stories, how AM was or is used in a good way. And then here we have topics that are more sort of overarching. We are talking about, we have Terry here in the audience, I think already he's giving us some views of the past. So he's looking back 10 years as we celebrate, of course, the 10 years, and we will look into the future. What's happening over the next 10 years? What are the projections for additive manufacturing? We will talk about mergers and acquisitions this afternoon. It's a very relevant topic at the moment in the industry. We will talk about business cases here on stage as well. So not for one specific industry, but overall. We'll talk about democratization of additive manufacturing. So which role does the accessibility of AM machines play in the adoption of additive manufacturing? I mean, these are all topics that are very relevant and that shape the future of additive manufacturing here this year at Formnext 2025.
Awesome.
Maybe we look a little bit, or we try to widen the viewpoint. Let's talk about the business situation right now. We experience tough times, and I think it's not so easy for you as organizers of a fair, but we have 800 plus exhibitors. But maybe Petra, you give us an impression about your assessment of the global economy. Is it very hard for you in doing your business right now, or do you see a very open-minded for an exhibition in additive manufacturing still?
Well, I mean, exhibitions always reflect markets. I mean, this is what they are. They are a reflection of the market. So to tell everybody, oh, it's easy, it's great, and it's ever growing, it's not true. Because at the end, as we reflect the market, we also reflect the challenges of the market. And I think even in these times, it's even more important. It's just what I said before. I mean, It's about collaboration, about working together, about networking, and about giving impulses, especially in times where some people have the feeling they are stuck a little bit. Yeah, no movement, nothing is happening. So I think this is also our role, and it's very important for us to stage this, to be there for it, to align it with different, what Christoph said, different formats, to also foster it a little bit, this exchange and this collaboration aspect. And I think also what we feel, and I think we are proud about that, is the relevance that Formnext as a brand created during the last 10 years is also something that you earn now. Yeah, because I think if people don't travel, if you have restrictions, if you just look at your budgets and you know, well, you can just do one, what do? Well, fortunately, you come to the most relevant point where you meet and where you hopefully get something for your money. Yeah, the return on invest if you're there. And fortunately, what we see is that Formnext seems to be the place they chose. And this is what we work for and work on, that this will stay that way. And ups and downs, I always said, I think there was a lot of roller coaster riding in the last 10 years. But as I like roller coasters, so for me, I think it's normal that you have downfalls, but then also rises again. And I think this is just something for me that shows how relevant our brand is, and we work for that and on that.
Yeah, and we will see, Terry, you mentioned Terry already. He will give us some new numbers and figures later, so we will see how the market develops. I remember his hockey stick. Maybe it's not quite like a hockey stick this year, but we will see. Sven, you wanted to add something?
I just wanted to add something to Peter, because, I mean, the two of us are experiencing Formnext also from an external view as we are joining you during these important days. And I must say, considering the recent years, Formnext and the team and the organization reflect so much how we grew in this industry. Because if there were any problems, I think about Corona, for example, we handled it, we faced it, we worked together with the partners and get it fixed and made it fantastic in the end. So, by the way, thank you to all of you representing the team, because you made this all possible. And I must admit, this is always a source of energy, I think, for all of us. I hope everybody agrees. And that's an additional achievement, in my opinion. So thanks for that.
Thank you.
Sorry.
Yeah, that's...
Definitely, guys. That's, it's also about setting impulses. Because, we can always, and it's very special, German maybe also, you can complain all the day. We can complain about European politics. We can complain about German politics. We can complain about geopolitics. But there are things happening which are not really in our scope of doing something about it or correcting about it. But what we can create here together with the industry is this gathering and this know-how transfer, this communication, this looking for collaboration possibilities. And that's only possible when people meet. And you just mentioned the pandemic. That was another milestone, as we all know, not a positive one. But, finally, also after the pandemic, this is really clear. When all these minds come together, we can create some positive impulses. And I think that's important over the next 4 days as well, because the technology is here, it arrived in the industrial environment, it can do things which were not possible before, also in an industrial scale and environment, and that's an achievement of the last 10 years as well. So that's really a positive impulse and outlook also for the next 10 years. So it's possible to deal with the challenges and like you say, to create something positive out of it. And I think that's also a message here for this Formnext.
And take the vibes and the energy.
Yeah,
this is it, basically. Yeah,
that's it. Yeah, thank you. You three, time runs fast. So while we enjoy our cake here a little bit, Terry will prepare himself for getting ready for his first keynote here on stage. And I would say now let's start into the trade fair show together and experience what we heard and have a look at all the technology and have good talks with the family. See you later.
Okay, the final lap, right square in the middle of the racetrack, as he has been all day long.
think something new under the sun. You can't take back them things you already done. No. You blame things that you do on somebody else. No. But they all see is you need help. But still you try so hard to cover up your games. Got you thinking, don't nobody see all this time. Ooh, it ain't nothing changed.
Since 2015, AMIT has been the heartbeat of Spain's additive manufacturing ecosystem, connecting people, technology, and purpose. Under the leadership of Nayara Zubizarreta, the association has united more than 100 members, from startups to global players, all the while shaping a vibrant AM community that now stands tall on the international stage. Through strategic collaborations, advocacy and European policy forums, and the creation of joint missions to Formnext, AMIT has transformed visibility into influence. Celebrating its 10th anniversary this year, AMIT embodies what true ambassadors do. That is, advance technology and build the communities that make progress possible. In Würzburg, SKZ, das Kunststoffzentrum, is bridging a crucial gap in the AM workforce. Together with the Chamber of Industry and Commerce, they've launched Germany's first certified industrial technician in additive manufacturing, a hands-on qualification with no academic barriers. This two-year program combines theory and real-world application, from polymer and metal 3D printing to safety, design, and production management, empowering technicians to become true AM professionals. With 19 experts and a curriculum rooted in practical learning, SKZ is turning curiosity into competence and ensuring that the future of additive manufacturing is powered by skilled, ready talent. Innovation starts with education, and at RWTH Aachen University's DAP Institute, they're redefining how the next generation learns additive manufacturing. Through a pioneering, data-driven learning framework, the DAP team combines Industry 4.0 analytics, immersive AR and VR experiences, and real-time labor market intelligence to keep education aligned with industry needs. Students explore complex AM processes hands-on, from design for additive manufacturing to powder bed fusion, guided by simulations that bring invisible forces to life. By blending research, technology, and pedagogy, RWTH Aachen's DAP is teaching AM and shaping the way future engineers think, learn, and lead in this industry.
Welcome to Formnext 2025 and welcome to our Formnext Insight experts here on industry stage in Hall D7, in Hall 11 D72. I'm very happy to have a first highlight for you guys here in the hall and for you in our live stream. It will be a hot topic of additive manufacturing because everybody's asking always about the numbers, about the figures. How is the market going? How is the market doing? How many industry sectors are doing well? How many industry sectors coming and joining the success story of additive manufacturing. And so I'm very happy to announce our first expert here on stage, Terry Wohlers. Terry is Head of Advisory Services and Market Intelligence of Wohlers Associates, and he's a resident in Washington, right, Terry? And he will present a retrospect and also an outlook of what's ahead in additive manufacturing. You are a real cornerstone of the industry. You know industry as well as nobody else, I think, and so we're very happy to have you here on stage. You will join us later on our panel discussion as well. But now we will get some insights from you. The stage is yours.
Well, thank you very much, Frank, for your kind words. That was very nice, very nice. Well, good morning, everyone. Welcome to day one of Formnext. This is exciting. Congratulations to Masago. Masago is the organization that organizes Formnext. Congrats on year 10 of this event. So it's great to be a part of it. And I'm excited about this week, and I hope you are too. There's just so much to see and do and learn, and the days go into the evenings and early mornings, and it's just a great time to be in Frankfurt. So thank you for being here. The next 25 minutes, I plan to talk about developments over the past 10 years, but I want to be brief on those because we don't want to focus too much on the past, but a little bit. And then the impact that applications have had and will continue to have in the future. China's role, a lot going on in that part of the world, a ton. And then the transformation that we're witnessing now and in the recent past, and what we'll see in the future in terms of how additive manufacturing has transformed some industrial sectors. So a little bit on that. First, a little bit about Wohlers Associates, powered by ASTM International. Our company was acquired 4 years ago. In fact, 4 years ago, this week is when we announced the acquisition of Wohlers Associates by ASTM International. And I think it's been a great partnership. The organization has grown. ASTM has put so many resources, and great people have joined since. We now have a team of 55 people, 38 of which are consultants, or we have access to work on advisory projects. So that's something that Wohlers Associates is always small and lean. We kept it that way for 35 years before the acquisition. We kept it that way on purpose. We wanted to keep it simple and lean, focusing on the technology, the market, the business, and not on management of people and that. So in any case, we're excited to have so many people working with us, and a lot of very talented people as well. If you want to learn more, see me or one of the others from our team. So in the past 10 years, the industry has grown by 18% every year on average. 18%. And that includes some pretty rough years, including 2020, 2021, the pandemic years. And so that's solid growth. Last year was a little soft. Business hasn't been as strong as it had been in the past. Even so, it grew to just under $22 billion. So it's beginning to get there as a serious business. We've seen companies struggle in the recent past, and here are some examples. Some have paid the ultimate price. A company that I visited in Spain a few years ago, in the lower left, I thought this company would thrive, and it did well for a very long time, but it went bankrupt. But you know, when companies undergo difficulties, they either strengthen or people pick them up and merge and take IP and make things even better. So it's natural for not all companies to make it. In fact, history shows that only about 10% of startup companies survive. So that means 9 out of 10 don't. And I think in additive, it's probably been less than that. So that's the good news. And we really have seen some strengthening. And really, you know, some have said, well, maybe we've bottomed out and there's only one direction to go, and that's up. And I think we are seeing companies become more efficient, become better by creating on value and long-term growth. And that's what you really have to do to survive and thrive in this business. Applications always have, and they continue to drive growth. Without applications, you really don't have an industry. Fried van Creen, who was the founder and now chairman of Materialize in Belgium, said that it's applications that will drive this industry forward. And I couldn't agree more. He said that several years ago, and I've put a lot of thought into it. And these are some examples across the various industries. So I'm going to talk about a few applications. If you look at data centers, they're popping up everywhere. And heat is an enemy of these servers. And you have to get rid of this heat so that the servers can run more efficiently. And so you can create heat sinks with additive manufacturing, as you see here. These are some pictures I shot about 1.5 years ago in Tokyo. A company by the name of Solize, we visited the company, and they're doing really impressive work. How many people knew about NVIDIA, I don't know, 5 years ago? Raise your hand. So maybe 7 or 8 of you. And of course, most of us know about it today. This company is valued at, in terms of market capitalization, $4.5 trillion. That's bigger than every country in the world except for 3. US, China, and Germany. Their gross domestic products are this big. All the other countries in the world are smaller than this one company, NVIDIA. So why do I mention NVIDIA? Well, they are creating the chips that need heat sinks like this, and they're largely tied to artificial intelligence applications. And so we're going to continue to see these data centers come together to help support AI, partly driving additive manufacturing. I'll give you one example here in a bit. I had the privilege of visiting this company a few weeks ago in Singapore. SIA Engineering is a 6,000 person company that they will repair from nose to tail. They had an A380, that's the big double-decker Airbus aircraft. They had several Boeing aircraft, but they'll repair anything and everything on the interior and exterior of these aircraft. And so I had the chance to tour this company, and one of their companies that works within this facility is Additive Flight Solutions, and they're owned by AM Craft. But in any case, these are seats, business class seats for aircraft. Their customers are airlines. And airlines can take 6 to 12 months to get replacement parts. So if something wears out or breaks or they need to replace, upgrade, it can take this long. Or in some cases, they can't get the parts at all. They're not available. So what do? Well, you can wait, or you can take those parts, you can re-engineer them and build them yourselves. And they're using additive manufacturing largely to build these parts because it's so expensive to create tooling for these parts, not only the time or expense, but also the time. And we're talking about, in some cases, only 40 parts per part number, meaning that the cost of them, if you build a mold, would be so expensive and so time consuming. So these are some example parts. When I was there, they were pointing out this piece here that the passenger controls, and they had difficulty where the customer would accidentally push a button. They wouldn't know they pushed it, like do not disturb, and then the flight attendant wouldn't be coming around. Well, you have the do not disturb sign on. And says, well, yeah, but I didn't push it. So anyway, that's an example part that they re-engineered, and they are 3D printing. And of course, they put the surface texture and color and so forth on it so that you can't tell how it was manufactured. And this particular work here is tied to Singapore Airlines, but they do work for Lufthansa and for many, many airlines around the world. But that's their customer, is the airline, not the airline manufacturer or the aircraft manufacturer, but the airlines themselves. This same company is using AI to help them with the whole process of not only manufacturing, but quoting the job, because that's a big part of it. They have to give the airlines a quote on what it's going to cost to build these parts. And so there's this company called Novanir. I met with the CEO. This was a few weeks ago at ICAM. ICAM is the International Conference on Advanced Manufacturing. It was in Las Vegas, Nevada. In any case, met the CEO there, and then I met with one of their customers in Singapore. In fact, it was the same Additive Flight Solutions customer. And so they're using a phone to, I'll call it scan, but take images of the part of interest. Now you say, well, that's not new, because I've been able to do that for years. Well, it's not photogrammetry. It's different than that. It takes images, and then the idea is to compare the image to a database of similar types of parts. So the idea is, let's say it's they're working on a armrest. They call it an arm cap. And suppose you want to scan the arm cap, but you can't see the underneath side because it's attached. Well, it's got this database of arm caps, and it says, it probably looks a bit like this on the underneath side. And so it fills it out on its own through this AI process. And so it's not engineering quality, but it's good enough for quoting. And that's what they're doing, is they're scanning for Singapore Airlines 500 different aircraft parts for quoting purposes. That's the kind of volume they're doing. And this is the way that companies are putting AI to work. Just one. I think AI is going to be used extensively for design, to the point where, I don't know, how many people have used, let's say, Gemini from Google to do image processing. How cool is that? Well, extend that into 3D, where you could maybe describe a part, and it could get you maybe not 100% of the way there, but maybe 25% or 50% of the way there. And I think that's, and there are some 3D AI tools out there now, but they're fairly crude. But in the future, you can envision where this might go from a design perspective. When I was leaving Singapore, I had heard years ago, maybe you saw this picture here of Tiffany. This hit the press maybe, I don't know, I'm going to guess maybe 2, 3, 4 years ago, something like that. And I was leaving from Terminal 3. I heard this is in Terminal 1. I had some extra time, so I took the trip over. I was walking up and I saw Louis Vuitton. I said, wow, that's pretty cool. But I tell you what, when you got close to this stole the show. This really was absolutely jaw-dropping. It was so much fun to see it up close. And so, but this is 3D printed. And this is additive construction. So it's not structural, but it adds real value in terms of aesthetic value. Really a good application of additive construction, in my view, a very good application. So the industry is faced with a number of challenges, and one is qualification and certification. So it can take 6 to 7 years to certify a metal part for flight on aircraft. 6 to 7 years. You can design a part in a few weeks or maybe a couple months, and you can manufacture it in, well, doesn't take that long now with additive. There may be some other post-processing, of course, so it's not just overnight. But in any case, it can be done in a few months. But then it sits and it takes 6 to 7 years to get it on the aircraft for flight. So we had a speaker at ICAM, this was a few weeks ago, as I mentioned, in Las Vegas, from Lockheed Martin. And he talked about this aircraft here. It was the first aircraft built totally by titanium. It flies at over Mach 3. This is a serious aircraft. Does anyone want to guess when it was built and how long it took to do it? Anybody? You're right. 1958, this thing was designed and built in 27 months. Now, we can do that, but now, today, with additive, it takes 6 to 7 years to get a part certified for a flight. So there's something wrong with this picture. So it was a wake-up call from this guy, this executive at Lockheed Martin, says, hey, our industry needs to do things differently. We need to get the FAA and other regulatory bodies on board to understand how we can streamline this. And I just had a good chat with a gentleman from GE Aviation, and they were working hard to do that very thing. And so I applaud this gentleman for, kind of whacking us on the side of the head and say, hey, wake up, guys and gals, we can do better. Another challenge is scaling. We've always had this challenge of getting, we can prototype parts, we can even do large or volumes of parts, but there's usually a certain break-even point where it becomes more expensive at a certain quantity to build parts additively. And that's been something that we've struggled with for, more than 3 decades. But you know what? China's doing it. They're doing it in a big way. Here's one example, a 3D printed foldable hinge that goes onto a mobile phone. They manufacture 1.5 million of these in 2023. And they're all the same. That's different than like Invisalign, Align Technology that builds the invisible braces. Yeah, they're doing millions. Each one's different, and they're not doing it in metal either. And so this is different. This is a first. And this is interesting. Watch parts, other phone parts in the millions to tens of millions built additively. Tens of millions. Footwear in the tens of millions. Automotive and dental part in the hundreds of millions built by additive manufacturing. China's doing it. I credit Ray Chu. Ray Chu is with PADT. He's from Taiwan. He's ran a company in additive manufacturing for about 30 years. He goes to China 3 to 4 times a year, and he's been reporting back what he's seen, both from a user and a producer standpoint, and really providing some enlightening information. Production tooling in the form of tires and tires for feet, known as shoes. And so they're doing tens of thousands of molds by additive manufacturing. This is a slide I showed here, it was either last year or the year before. And the reason I wanted to share it again is that the build volume in the lower right is an EOS M290, a very popular platform. And then 4 out of the 5 in the upper right shows the volumes of these bigger scale machines. The print is quite small, but let me read the one in the upper left. It's the E+ 3D, 64 700-watt lasers working together. That machine has the build volume of the 290, EOS M290, by 228 times. So this is one way the Chinese is scaling, is through scaling the machine so you can pack more parts. There is an economy of scale through additive manufacturing. So if you can build more parts at one time, they become less expensive. And of course, you can build them more quickly as well. Some examples of producers of materials and systems. 4 of the companies in China have gone from 0 to $200 million in revenue in the last 10 years. Bamboo Labs, in terms of revenue, is now the largest in the world, and they're only 5 years old. Incredible. And what's more, common metals and polymers are at a high volume, high quality, and at a lower cost than those found in the West. Some manufacturers of machines in China, BLT, Bright Laser Technology, they are running, so they started out as a service provider. I met with the CEO many years ago. They were still a service provider, but they were rolling out their first machine. They were running EOS machines at the time, a lot of them, And today, they're running 400 of the large metal powder bed fusion machines. They have more than 400 CNC machines just to process the parts coming off their additive machines. So this is serious manufacturing they're doing. And they're also producing their own powders with these atomizers. So they are really taking things from, start to finish. Fohan 3D, they have 800 large-scale machines. They ship 20 million parts in 2023. And then WeNext, these may be companies you and I have never heard of before. They're running 600 large machines, 200 CNC machines. They ship 13 million parts in 2023. So China has figured out how to scale in a big way. And so China has learned a lot from the West for a very long time now. Maybe it's time for us to take a closer look at what China's doing. So the West, though, has transformed several industries. One is hearing instruments. That was really the first application of AM where it became a point where all of the, in this case, hearing aid manufacturers got on board. Not all, but all the popular ones back many years ago. And today that's a standard for building custom fit in-the-ear hearing aids. Dental, we're seeing a lot of activity around that and a transformation. Orthopedic implants, aerospace is just look around. Rocket engines is a part of aerospace, but I wanted to break that out because there's just so much activity around rocket engines. And then I wanted to mention that for us to grow as an industry, we need industry standards, we need certifications. There's a lot of things we need. One is a new program that was introduced by AS Team International just recently, and it's called the Additive Manufacturing Certification Program. Compared to like AS 9001, where that's a certification program, and it's important to have that certification if you're working in a particular industry. But it's very focused. This is tied to additive manufacturing only. And these are the companies that have gotten on board and helped guide the thinking around developing this certification. So stay tuned. You're going to be hearing more about this certification program because I believe that in the future, if you want to be a manufacturer of additive manufacturing, if you want to use the technology to manufacture, you're going to need something similar to this, if not this certification, to really to demonstrate, to have an outside auditor come in and look at you, a third-party group, and then certify you as, yes, you have met these standards. So in summary, strong growth over the past 10 years. The industry will strengthen, it has. Applications drive growth. China is in the lead, and it's in the lead by far. Now, there may be certain little areas where the West still has an advantage, but for the most part, China's in the lead. And applications drive growth. And thank you very much for your attention. Oh, and we are just opposite of where we're standing right here in this hall. And you're welcome. We have, I think, 16, maybe even 18 if you count others that have shown up. So we'd love to meet you in person and come over and say hello. Thank you very much.
Thank you very much, and a round of applause for you, Terry. Maybe we have 1 minute left for one question. From your perspective, you mentioned that the scale up, and I think that's a very often discussed topic. Which industry sector will be leading in scale up? Where do you see, those the industry scale of usage of use of AM?
Yeah, the ones that we've seen, and I think we'll see more of, and that's aerospace and the rocket engines that I mentioned before. Although scaling, the volumes are fairly low there. I think orthopedic manufacturing, medical implants and healthcare in general, dental.
And that is worldwide, or is it? Do you say it for a U.S. market or for Europe market?
Well, it'll vary from region to region. For example, healthcare is different in the U.S. than it is in parts of Europe or in developing regions of the world, Asia, for example. So it will vary. But for those who have access to technology and are using, you know, the more developed nations, it'll be fairly universal, but some will lead and others will follow, but not very far behind.
Okay, thank you very much.
Oh, you're welcome.
We will have you later, and then on our panel discussion, we will dive into the topic of certification and so on. We will dive deeper in that aspect as well, I think, because it's very interesting. But now we are running out of time. Thank you very much,
Yeah,
Terry,
thank you, Frank.
for having you
Appreciate
here.
it. Thanks.
And sharing your thoughts. Yeah, we will see you again at 11:40, as I said. But first, after a short break, we will have the next highlight presentation here on stage, and it's a highlight interview. We will see.
From empathy to innovation, Grabit is redefining assistive design. Born from a personal story and inspired by real human need, this project combines design, technology, and sustainability to support people with hand impairments. Through 3 distinct forms, a ball, a ring, and a cone, Grabit enables rehabilitation, flexibility, and warmth therapy in everyday life. Each object is 3D printed with adaptive TPU lattice structures that respond to touch, pressure, and temperature, blending science and compassion in perfect balance. With every detail, Grabit restores independence, dignity, and joy, proving that true design begins with empathy. Precision meets performance in the IKM Flux Vaporizer, a breakthrough that redefines how we measure energy. This new LNG vaporization system uses generative design and additive manufacturing to more than double measurement accuracy in liquefied natural gas operations. Developed through collaboration between IKM, EOS, Valand, and TOFFEX, the team created a sculptural, fully self-supporting component that optimizes heat transfer and reduces material waste. Field tests at Equinor's LNG plant confirmed unprecedented stability and accuracy, setting a new standard for sustainable industrial design. The IKM Flux Vaporizer demonstrates how digital innovation can transform energy infrastructure and power a more transparent, efficient future. In Kenya, a remarkable collaboration is changing lives, one child at a time. The Limkind Foundation, together with HP and global partners, is using 3D printing to design and produce custom prosthetic sockets, each one made to fit a child's unique needs and offered completely free of charge. With HP's multi-jet fusion technology, these lightweight, durable sockets restore more than mobility. They restore confidence, dignity, and independence. Each smile, each step, tells a story of what's possible when innovation meets compassion. A symbol of how additive manufacturing can build a more inclusive and human-centered world, one child at a time.
As a consultant, I make sure to steer my clients towards personalized production to suit their specific wants and needs. My purpose, making not just serious production, but also making customization affordable, be it for prototypes, spare parts, or mass customization. This is where additive manufacturing gives you a competitive edge. When it comes to batch size 1, I have observed this very trend in several industries. This is what brings me to Formnext, my quest for industrially viable solutions.
Welcome to Formnext 2025 and welcome here to our industry stage. And I'm very happy that you join us with our next highlight here on stage. Yeah, she is an experienced strategist and networker. She has a keen sense for trends and innovation and held various management positions at Deutsche Bahn for over 25 years. She is in the additive manufacturing area since, I don't know, we will ask her. And when she joined Deutsche Bahn, she had a vision. She wanted to install additive manufacturing, and I think she did a good job there. She now has realized over 100,000 parts in 12 technologies and 1,000 different applications. Please join me in welcoming the head of additive manufacturing at Deutsche Bahn, Stefanie Brickwede.
Dankeschön.
Nimm Platz.
Ja.
Yeah, Stefanie, you just arrived, or had you a chance to walk around and had a look at the booths?
In fact, I arrived already yesterday, but I was quite busy because yesterday we already celebrated our 10th anniversary of additive manufacturing at the German railway company Deutsche Bahn. So this morning I had the chance to walk around a little bit. Yeah, and now I'm here.
Did you see the cake we had for the Mesago team this morning?
No, not yet.
Well, maybe you were a little bit jealous about that because it was a really big one and a very heavy one. Maybe there is something behind the stage so you can have the one or the other piece. Yeah, as you said, you had the 10 years anniversary at Deutsche Bahn, so it was not it was just like a coincidence with Formnext. It was not has nothing to do with Formnext. You didn't know about Formnext then in this time.
No, not at that time. Yeah, at that time when we started with our first activities at Deutsche Bahn, we wanted to focus on spare parts, and spare parts we couldn't get anymore. And that is definitely a huge task because sometimes we're waiting for spare parts up to 3 years. And yeah, but it was not due to Formnext, although I must admit that it really helps every year to get in contact with new players, also with old partners. It's the place to be in November, definitely.
But I want to make a little time travel with you, looking at these 10 years ago. We had it with a management team this morning, and I want to make the same journey with you as well. Can you remember the first day or the moment when you realized, okay, we do not want to wait longer for these spare parts? You could have 1,000 other options, make pressure on your suppliers or build own facilities. I don't know, but you decided to go into the additive manufacturing. What was the moment? Do you remember that moment? What was a team meeting or?
Yeah, so maybe there were even different moments. One was, for instance, at that point, CeBIT, the huge fair for IT, still existed in Hanover. And I wanted to visit that. And I didn't have any time for preparing. So I told my young students, please do a visit and tell me where to go. And then they said, you have to take a look at 3D printing. And I said, oh, wow, okay. And then I saw that, and nowadays we could really just laugh about that because that was the usual desktop printer. But in that moment, I was also busy with some procurement topics at that time in a project. I thought that might be the solution for those parts we can't get anymore. And I came back very enthusiastic, and I went to our CPO and his whole team, and I said, I have the solution. And they said, oh, no, we are not going to do that. Automotive guys should do this before, and we are just the first follower, but no. Now we are exactly 10 years after. We have printed even 200,000 parts now.
200,000. I mentioned 100,000. Yeah.
Yeah,
I didn't
and
know about the two.
And what I really love is that we even tried out 12 different technologies. And I think this is for such a corporate, and we are not a constructive company. Yeah, we can't forget that. We're just an operator. It's a very, very broad variety. And so we made a lot of use of additive manufacturing.
But let's talk about how to convince your bosses at that time or your partners in the company. What was the process in convincing? Because my impression is that we always have slightly problems, to say it like that, with change management. So somebody's coming with a new idea. And maybe it's a German thing, I don't know. But you come with a new idea, I don't know, I'm not so sure about, there are so many problems coming along. How did you get your bosses and your colleagues convinced in talking about, just imagine how it could be, not a step in doing it, just about being on the table as topic?
Yeah, first of all, maybe especially as Germans or Europeans, we are sometimes a bit too much on the negative side. If we talk about the potential of things and what we can do with that and try to create a vision, then you can also get people involved. Yeah, and we are, especially in the AM sector, we are always talking about the hype and that we have to get rid of the hype. I mean, the hype helped us to come exactly where we are now. And yeah, how to convince them? First, we started without asking. Yeah, we simply started with a couple of things, and something which was also a bit different at that time. Usually in a big corporate, and I mean Deutsche Bahn, at that time we had 300,000 employees, and it's a very big company. We usually, if you want to start a corporate project, you would go to your CTOs and ask them, could you please send us some of your colleagues? And we did not do that. Yeah. So what we did is we shouted into the company and said, we are going to start with additive manufacturing or with 3D printing. Who really wants to join us? No matter which hierarchy level, no matter what you're doing so far, how can you approach us? Just contact us and then you're in. And at that time, it was a totally different approach. And that was also due to the experiences I've made before. Yeah? And usually in a big corporate, you always try to find the compromise between all the partners. And of course, then it's always the lowest level of agreement, so to say. And this time we wanted to go for the big thing. Yeah? And that was also a great start. And especially in additive manufacturing, there are so many people out there who really love the technology, who are really addicted. Yeah, you can hardly find that in any other field. And we try to get them involved, and that worked out properly.
Convincing by just doing.
Yeah, making.
That's great. Did you start at one service point or one facility, or did you from the beginning spread it in the company?
No, first of all, we wanted to get some experience. Yeah, and that was at that point we wanted to try out things, and we worked explicitly with printing service bureaus or service providers, because they have the knowledge, they have the machines, you don't need any investment, you can simply start.
So you didn't print in-house?
No, exactly.
But with your partners, okay.
And until today, of course, we now have some printing facilities, but a very big part of our parts is still produced by service bureaus and providers. So that plays a very big role. And this is, I would also love to give as an advice to companies who are just about to start. Just do it. Don't think in the first moment to buy a machine, yeah? Because that usually comes later. If you have some experience, then you know exactly what kind of materials suits which machine, what do you
can learn together with a supplier, right?
Yeah. And at that point, we wanted to get in touch also with other companies and try to find out what kind of experiences have they made concerning materials and technologies and especially use cases. And at that point, we were also looking for existing networks to get in such an exchange, and we didn't find an appropriate one, so we founded our own one. And that was Mobility Goes Additive. Meanwhile, we've enlarged that to also medical, defense, aero and space, construction, so whatever you can think about in additive manufacturing. And this is also maybe some of our experience, yeah? Try to find others. Get into an exchange and talk about what were your experiences and what can we learn from that, because then you can scale much faster and higher.
But let's stay a little bit longer at the beginnings when you work together with your suppliers. I would like to know or to understand how, for example, did you talk to them about quality issues, for example? In my impression, it was maybe in the beginning not so easy to get the quality you wanted, or the testing, even doing the testing or the certification to use a printed part in the railway. So was it a tough time over then, or was it easy for you to manage that?
I mean, at the first step, it was like, oh, I've heard about 3D printing. My son has a 3D printer, and they do just Star Wars figurines. And I will not have that in a safety-oriented corporate like Deutsche Bahn. So we really had to convince people, and we had to convince a lot of people. And the big advantage of AM is that it's so haptic. You can touch it. Yeah, and this is what we also did. We took some parts with us to those roadshow meetings we did in our maintenance workshops. And the first thing was a printed device for an air conditioning system. And we made that from titanium at that point in cooperation with Siemens. And when you put something like that on the table and show what the technology is capable to do, yeah, so then you can convince people what we can do with that technology.
But how did you manage to get the quality department, for example, I think they had to learn a lot of things. They had to find new testing methods or new kinds of certifications together with the supplier. So it was, I think, it was a totally new workflow you had to install, right?
I mean, everybody had to learn a lot, yeah? So our people had to learn a lot about the technology is existing and it's reliable, but also the AM industry had to learn a lot. So we had to bring them together and to teach them. And yeah, of course, you need some other parts of, or some other kinds of testing, but we always have to be on the safe side, yeah? And this is something we also discussed with the AM industry. Why do you have to print that part in aluminium? Why can't we just take fiber-enforced polymers? Yeah, because we have a certification for aluminium printed parts.
Okay.
Or aluminium parts. And if you want to reproduce parts, then you have to stick with form, fit, function to the previous part as much as possible. Otherwise, you will lose your certification. And if you lose certification for a certain amount of parts in your train, you will lose the certification for the whole train. Yeah, and nobody in such a corporate wants to risk that. So this is also one of the reasons why we always were very close to the previous design. And yeah, maybe also some kind of discussion also with the AM industry, because they always approached me and said, you're losing the full potential of AM, you have to do design for additive. And I always said, no, I don't have to do that. I have to do what a corporate needs. And if the corporate needs the previous design, then we stick to that. Yeah. So we had learnings on both sides.
Is there one lesson learned? You know, I dive so deep into that because my impression is that in the audience there might be the one or the other who wants to convince his company and wants to go forward, because the family here is so enthusiastic about 3D printing, but there are so many outside who are not. So in my impression, it's still today the case. do you have one, so we move on to next topics, but so do you have one a lesson learned, one single advice or hint for people?
Oh, I have not just one advice. But what is really crucial, if you want to start with additive manufacturing and you want to convince your management, what I can just recommend is try to fix what are the effects you're gaining with AM. Yeah, so we can tell for every part we reproduce, what is the effect? Was it a standstill? Was it a minimum order quantity we do not need anymore? Can we save warehouse costs? There are different kind of effects which you can approach. And one of the, maybe the challenges is that the whole technology is driven by engineers. And I must admit, I'm not an engineer. Yeah, I come from business administration. So with my colleagues, and that's always something a team does, it's not just a single person, we decided that we want to stick also to the effects. So if someone approaches us now and says, yeah, what are you doing? Is that really relevant? Yeah, it is. I can have a price tag and effects on every part we've printed. And so sometimes, of course, it's a bit more work because you have to discuss before you print parts or during you print parts to have the exact number of the financial effect. But afterwards, maybe there might be also a company getting into financial struggles. Then you already have all your arguments at hand and say, this is important because, and then you can also convince a CFO.
Mm-hmm. And in Deutsche Bahn, you made the next step. So when I got it right, you when there is a supply of a new train, then you say there have to be at least some parts to be reproduced by 3D printing, so that you will not have the problem in future to get the CAD file or something like that. Can you describe your method there a little bit more, please?
So our first step was what we've already discussed, reproducing spare parts. Then the next step was printing more tooling devices. Okay. And then we decided maybe we have to think about more getting the whole supply chain to the beginning. Yeah, so at the moment, at the time, we were still at the end.
Beginning means the production of the train initially at a supplier.
Exactly.
Siemens or Alstom or something.
And we are not the suppliers, we are just the operators. So we tried to discuss with our OEMs like Siemens, Alstom, with their second and third tier suppliers, what can we do with additive manufacturing? And then we decided for every tender for new trains, we want to integrate a number of 10% of the parts have to be printable. And we define which parts. And with that, we really have huge savings. This is what we are aiming for. Because in future, we usually have to store spare parts. You get guarantees, service level agreements for the first 15 years of operation. And then the suppliers usually tell, now we are out of the game, please put everything on stock you might need in the upcoming next 20 to 30 years. Who can really do that and assume that? Nobody. So, we have a huge warehouse, which means we have spare parts on stock worth 1.8 billion euros a year. And we know already, and we agree with that with the rail industry, we could print 10% out of that. That is real cash out. Yeah, so we could save more than 100 million euros. And this is what we call the road to 100 million. And this is what we are aiming for now. And therefore, we also need the industry. And this is why we've integrated an average percentage of 10% of printable parts, which usually costs us a lot in after sales, and if we want to have them stored until the end of the life cycle of those trains.
And are your suppliers open-minded for that approach, or do they experience it as a big problem for them to change their sort of production?
I mean, usually it's always a process, yeah? First of all, they try, there's something, they want to rule us and regulate us. And
again, the change management with the suppliers, yeah.
But I'm really glad that we have very open-minded OEMs on the other side, yeah? And they said, no, it's really good that you put this in the tenders, because then also within those other companies, like the suppliers on the supplier side, they have also something at hand which they can use in their corporates to argue why they have to focus on additive manufacturing. And I guess that helped the whole industry. The big suppliers, they all know what additive manufacturing means. The smaller ones, they still have to learn, and so we are trying to push the whole industry, and this is only something which huge companies can do. Yeah, and that's an advantage or disadvantage, however you want to look at that, but this is what we are doing.
Okay. Yeah, maybe we shift a little bit the focus. You already mentioned your Mobility Goes Additive initiative, the network. And it fits, I think, to an exhibition like that, where, you know, it's already crowded here at our booth, and it's so good to see in the first hours of the exhibition that so many people are coming here. And as we discussed this morning, they are not coming just because they want to look at a product and buy it maybe later. I think it's a lot about networking here, and that was an aspect which you mentioned already, but I want to dive a little bit deeper into that one. Why is it so important for you to have a network? And you added a little bit later the medicine to the network, or created a new. Please describe it a little bit better. And why medicine at that time? So first question, why the network, and why is it so important for you, and what are you really doing there? So what is the outcome of such a network?
So, I mean, we all want to scale additive manufacturing. And how can you scale faster if you share experiences? And therefore, you need a group of like-minded people. And if you do so, and if you overcome the hurdles together and jointly, then it's cheaper, easier, and faster for all of them. And that was the idea of MGA. And this, we started with rail-dedicated subjects. But very soon after, we were asked by our members, we have similar topics and similar challenges in the medical sector. When could you please start with medical? And of course, that has nothing to do with rail anymore. But on an overall global perspective, the challenges are quite similar if you have a railway company or an aerospace company or a hospital. If you want to integrate additive manufacturing, it's always the same, it follows the same rules. This is why we've, for instance, in the network, brought our experiences together and wrote a book about change management in AM to help others to accelerate faster. And that is the typical topic, yeah? And with the network, just to give you maybe an example also from the rail industry, Deutsche Bahn was one of the first ones, and I would say now they are more or less the leading ones in the world in the rail sector, on the operator side. But we still learn from each other. So this afternoon, we will meet again with our colleagues from 8 European rail and public transport companies. And for instance, the Dutch colleagues, they came up with that idea of integrated AM and tenders. Yeah, the tenders of Deutsche Bahn are a bit bigger, so the effect might be a bit bigger, but the idea originally came from another company. And if you are open to adopt and to integrate other ideas, then it makes sense for all of us. And this is what we are doing constantly, also in the medical field. We know exactly what could be done, and if we give others the chance to learn from each other, then it helps the whole industry.
Mm-hmm. Do you now you have a good audience here? Do you need the one or the other company joining you, or the competitiveness maybe, or a new aspects like you could use somebody knowing about materials or something else, or do you lack some expert in your network?
I would like to welcome all the experts. Yeah, so we need experts from all fields, all sectors, and also from all the companies throughout the supply chain. That is really, really important. And I mean, everybody's talking about defense nowadays. So we're going to meet with some defense companies and armies tomorrow. And also there, the exchange is so important. Yeah? So they have very similar materials and technologies which we use in rail. What I would like to point out, and what is really important to us, is the standardization. And standardization is assumed not to be very sexy. I think it's the most crucial aspect at the moment for additive manufacturing. If we lose traction in standardization, if we do not standardize more, then we will never jump over certain hurdles. And this is what we all want to do. And this is why we all have to engage in standardization. And there are so many really dedicated experts in that, and it's really a lot of fun. So I, as someone coming from business administration, jumped into that, so all the engineers can do the same. I'm absolutely convinced. And we need more cool people on the standardization part.
Okay, perfect. Thank you very much. That's kind of a last word. Just one short answer. I know you have two sons. Did you get them into 3D printing already, or do they say what is mom doing? It's not business of ours?
No. Hopefully they will not be angry with me in some decades, but at the moment they are both engineering addicted, and the older one, I put them when he was 6 in front of a desktop printer, and he could really literally watch for hours how the printer is proceeding. And since he's 8, he wants to become an engineer. So keep our fingers crossed. That's the next generation.
Okay, next generation coming. Stephanie, thank you very much for being here with us. Time runs fast. We could talk for hours, but we have the next highlight here. Thank you very much. You're around here and you are on stage again this week. So the audience, if you want to meet Stephanie again, so make sure to look at our timetable. Yeah, thank you very much for joining us here in our live stream. And after a short break, we will have the next highlight here on stage. See you later.
Designing geometrically complex components and finding solutions for specialized functions. Isn't it fascinating? Just imagine combining entire assemblies into a single part. The exciting thing about 3D printing is, if you can design it in the software, you can produce it. The exhibitors at Formnext demonstrate such groundbreaking feats. It's becoming faster, its process stability is improving, and process chains are becoming more automated. The era of design freedom and innovation has now arrived in industrial production.
With Innov.IQ, Aerofio and Angle showcase how additive manufacturing and digital injection molding are redefining modern toolmaking. Their fully 3D printed metal mold integrates conformal cooling channels and Angle's IQ clamp and IQ flow control, creating a seamless bridge between physical performance and digital precision. The results speak for themselves. Mold weight is reduced by 75%, energy savings of 30%, clamp forces reduced by 15%, and cycle times shortened by 10 seconds, all while improving sustainability and extending tool life. Even ultra-thin parts with walls as fine as 1 millimeter can now be produced efficiently and consistently. Innov.IQ is proving that when advanced engineering meets additive innovation, efficiency becomes more than a goal. It becomes the new standard. With Coratech Mythos, Imezicor introduces the world's first fully automated hybrid manufacturing system, uniting additive coating, PEM, with precision 5-axis milling and grinding. This innovation enables multi-material, multi-color dental restorations of exceptional accuracy, surface quality, and beauty. From crowns and bridges to implant frameworks, a fully digital CAD/CAM workflow minimizes manual steps, accelerates production, and delivers unmatched process reliability. With the ability to process up to 7 materials, including ceramics, composites, polymers, and zirconia, Mythos sets new benchmarks in efficiency, sustainability, and reproducibility. Scheduled for market launch in 2026, this system improves workflows. It reimagines them, bringing the next era of digital dentistry to life. Lempe Mosner Sinto is transforming foundry manufacturing with one of the fastest binder jetting systems in the world, already producing over 1,100 sand cores per day at the BMW Group. This integrated solution covers the entire process chain, from raw material preparation and printing to automated desanding, cleaning, and measurement, all monitored in real time with precision accuracy of plus or minus 0.3 millimeters. With printing speeds reaching 850 millimeters per second and the Lempe Printing Wizard software enabling flexible job management, the system delivers industrial-scale automation and consistency. By using inorganic binders and AM-optimized geometries, cast parts such as heat exchangers, e-motor housings, and water jacket cores now achieve up to 15% lower fuel consumption. This is innovation. This is industrial evolution, paving the way for a sustainable, data-driven foundry of the future.
Welcome back to Formnext 2025 and welcome back here to our stage in Hall 11D72 and welcome back to our live stream, and I'm very happy to have the next highlight here prepared for you in the hall and for you at screens at home. Yeah, I have experts here joining me on stage. And we want to dive into the topic of the last 10 years, and maybe we have the one or the other outlook where the industry might be going. And let me introduce our panel here with me. Yeah, I already mentioned this morning, Terry had a presentation. And I don't know if you followed his presentation, because he gave a lot of answers, but maybe you have to give it twice because not everybody was there. So I'm very happy to have him here. Terry Wohlers, he has been one of the most influential voices in additive manufacturing for more than 3 decades, so a lot more than Formnext is old. He advised hundreds of organizations worldwide and continues to shape how the industry understands its own progress. Terry, again, good to have you here.
Oh, thank you, Frank. Appreciate it.
Arvid Eirich, he leads Deutsche Bahn's additive manufacturing program, transforming how one of Europe's largest transportation companies manage spare parts and innovation. And we just had Stephanie, your colleague, here on stage, and she already gave us some insights.
Yes.
Maybe you can add to one or the other, or maybe you have different views. We come to that back later. Arvid, good to have you here.
Thank you, Frank.
Michael Patch, he's editor-in-chief of 3D printing industry. Michael has documented and analyzed the global AM landscape as the owner, and some say one of the most, but he says the most read 3D printing publication. And his perspective, he will bridge for us today technology, economics, and communication. And we will see, maybe he can give us some insights how the world perceives the industry of AM. Good to have you here, Michael. Thank you for joining us.
My editor's pen out. I noticed it's 3D printing industry, not 3D printing industries.
Ah, okay. So maybe we can change the slide while we are talking. And I'm very happy to have Professor Dr. Ingomar Kelbassa with us. He's Executive Director of Fraunhofer IAPT. I think you are a former Siemens specialist, right? I remember that correctly. And he brings deep expertise from both research and industry. That's why I remembered the Siemens. His work focuses on turning additive manufacturing into a truly industrial technology. And one of your highlights and headlines is industrialization of additive. And I think that's a very important topic. And maybe we can bridge the 10 years perspective, or maybe 30 years perspective together of industrialization. Yeah, but let's start with Terry. You've been documenting the evolution of additive manufacturing for such a long time. If you had to sum up let's say the last 10 years, but if you like, make it longer. What stands out to you most? What is the most important milestone you remember?
Wow, that's a challenging question. I would say this, that where additive manufacturing provides real value, it has a future, and it can drive growth within startups, within large corporations, agencies within the government, militaries.
But when you look back, is there a milestone which you remember, where you say, I'm sitting here in the office and that has happened, and then I knew that would change our perspective of manufacturing?
Yeah, I mean, an executive at Stryker Corporation that makes the implants for, spinal implants and knees, hips, and so forth. When that person said that in the future, 100% of all of our products will be manufactured by AM, it's like, wow. Now that has an impact. That gets your attention, and you think about how it is transforming healthcare and implants in particular. That's staggering. Dental, the same thing. I mean, we're seeing so many dental products being produced in that way. So I think healthcare in general, and then if you look at aerospace, but that's exciting. It's good to see the progress, I guess, because, back in the early days, back in the late 80s and 90s, you did not see this sort of thing. It was very experimental, and, things didn't work very well. Materials were poor. A lot of things were poor back then, but there's a lot of promise. And now we're seeing the delivery of these promises.
I always remember your hockey stick, and but each hockey stick has a beginning, and the beginning is very flat. Yeah. The times when you dived in the numbers, and they didn't really. You always maybe had in mind it. Sometime or in some years I might be developing a hockey stick, but in the beginning, where it was so small,
it was very flat.
Yeah. What was your impression then?
My impression was that there's promise. The light bulb went on among a lot of us, and we was like, oh yeah, this has got a future. It's going to take time. A lot of things don't develop. It takes a whole human generation for them to really develop, which is like 18, 20 years. And so people were patient.
And you were patient, obviously. Yeah. You were patient and staying with us, with a family of additive manufacturing for such a long time. Yeah, we talked a lot about mindset and changing mindsets. I want to get you into the discussion, Stephanie. I asked her a lot about this topic. Do you remember when your mind changed to additive manufacturing, or did you have a printer in your child's room?
So no, I didn't have a printer. So it was like with Stephanie together 10 years ago when we first time have seen a 3D printer. And when I also remembered, as I was in the university, I've studied mechanical engineering with economics together. I remembered, okay, you had a small slot about additive manufacturing, and let's have a look on it. And as we were in Hanover, at the Hanover Fair, and we have seen just a small desktop printer, Stephanie and we said, okay, that's maybe a really, really good thing.
So you were already together then?
We were already together.
Ah,
we were
okay.
like innovation scouts on the Hanover Fair. And yeah, and it was really exciting because when we got back to our company and made a kickoff and said, okay, every department come and let's brainstorm what can we do with additive manufacturing. And the main point, our focus, what we are doing now was just a small posted printing spare parts with a lot of ideas. And that's in the moment, I think this was 10 years ago, the point where I got addicted to 3D printing, and yeah, and we addicted a lot of other people within the company.
Yeah, that took a long road. What was the main aspect? How to convince your bosses and your colleagues?
So you have to think that we are a highly regulated industry, and we are all, let's say, we don't want to take risks. Because it's every time we say, okay, if we change something, it's about something can happen, it can be an accident or something like that. And when we are in the media and we don't want to change anything. And every time people said, okay, we don't want to change that. But like Stephanie already mentioned, we came from the economic side. We said, okay, we can make it cheaper, we can save money, and we can be faster and gain also know-how. Because the German railway company, we are not a manufacturer. We are a service provider. We are buying a train, running a service, and maintain them. So we didn't have in the past this deep technological know-how of trains in the past. So it was not easy, but we had to convince a lot of them. And maybe she already mentioned it. We are now 10 years in additive manufacturing. And the first 5 years, like you said, it was a flat line. And I don't know what happened, but 2019, this line of parts goes like a hockey stick up, and it's not stopping in the moment. So we had, in the first 5 years, we have printed maybe 1,000 parts, 2,000 parts. And in the last 5 years, we are now at 200,000 parts. So it's starting to grow and grow, yeah. And people are knowing it now. Additive manufacturing, and
they are convinced right now.
And they are convinced, and the young people are knowing additive manufacturing. So I know 10 years ago I had to explain to friends of me what I'm doing, what is 3D printing, and so on. And if I'm now meeting new people, a new guy, and telling him, yeah, I'm working in 3D printing, yeah, I know what 3D printing is.
Yeah, Michael, as someone observing and reporting on the industry on a daily basis, how has the narrative around AM changed from your perspective over the last years, or do you know what changed 5 years ago that they made a hockey stick in the printing parts as well?
Good question. I mean, 5 years ago, none of us were here, right? We were all sort of sitting in our front rooms or wherever, watching Formnext sort of live on TV, as some people, I guess, are...
Terry has been here.
I'm talking about...
You attended 5 years ago.
Yeah, 2020, in COVID times, right?
Ah, in COVID times. Now I got you. Yeah.
So, nobody was here.
Yeah, now I got you.
And I think that kind of, pun, please excuse it, but gave the industry a bit of a shot in the arm, right? The world stopped. People pivoted, started using their skills to sort of help the efforts which were going on. And that did sort of expand the sort of a renewed interest in additive again. And I think, what Arvid was saying just then, I'm glad that you hear that lots of people actually know what additive is now. That's not the story I always hear. And I was talking to a CEO this morning, and he says the biggest challenge still is education. And, this is a company which is doing production, which has got parts, probably some of you may even be wearing them. And his battle is still educating people. So, we can operate in this bubble sometimes where we assume that everyone's got the same knowledge we have. And there's still a lot of work to be done. We're still a drop in the ocean. We take, take Terry's numbers. We're 20 billion as an industry? Look at that as a fraction of global manufacturing, a fraction of injection molding, a fraction of how plastics or metals are used in manufacturing. So
less than 2%.
Yeah, it's tiny,
like
right?
Less than 1.5% of the entire manufacturing economy worldwide.
Well, I mean, and like you were saying, it's incremental. I think, you know, coming here sort of personally since 2016, you know, what's changed? I still hear the same language. I still hear it's all about the application. You know, well, we were talking about that a while ago, right? Progress is glacial. You know, I think, is that a problem? It is if you run out of capital, but I think that's how it's going to be. I think, you know, this industry is great to work in. I think when you've been working in it for a long time, you can get fatigued. And I think sometimes that translates into some of the things you see and read on social media. So on a daily basis, when I'm kind of checking the feeds, I do see things which maybe don't reflect the reality, but do work on social media. I think what's changed, people have changed. People have learned more. People have worked out how to make the connections with the bigger ecosystem. I think that language has gone from, you know, when I still joined the industry in 2012, 2011, disruption was what we heard, you know? No one wants to be disrupted.
Was it a moment when you decided to? Are you founder? You're owner of your publication. Are you the founder as well?
I founded previous companies, but I was not the founder of 3DPI. That was founded by somebody else, and it's been around for longer than I've been around.
But can you remember the moment when you joined in, when you came in and said, "Okay, that could be a good platform for me, and I want to give my energy here"?
Well, I was already operating in the industry before I was invited to sort of to initially run 3DPI, and then later on sort of.
So you have been addicted already.
Well, yes, you could say that. You could say that.
Perfect. You mentioned the people who want to be educated, and that brings me to Ingo. I'm not sure how much educational work you're doing, but you are for sure doing research, and you are the one for me in my mind who builds the bridge between research and industry. Can you remember when you started into the additive manufacturing business?
Oh, I can remember that very easily because I started in 2000, so I'm in the AM arena not that long as Terry, but meanwhile for 25 years.
Wow.
Started in Aachen at RWTH Aachen University and carrying out there my diploma thesis, and that was already an AM. Yeah, and we do have the base patent, selective laser melting, LPBF, which is right now in this year, 1995 it was, so 30 years old, right? So metal powder bed based is 30 years old. And to answer your question, Frank, of course we carry out and conduct R&D more from the applied perspective. Of course, what you said is perfectly right. So the mission and the vision is really to industrialize additive manufacturing. And on the other hand, we also conduct basic and fundamental R&D, so TRLs, so technology readiness levels less than and below 3 at the University of Hamburg, University of Technology. And so we are bridging the gap in between really basic and fundamental outcome and industrial implementation. And when it comes to pure education, of course, we do have courses for students, engineering students, mechanical engineering, academia, but also we are into the education of blue collars, because this is really real world problems. You do not want to recruit 3 Dr. Inks and 3 PhDs to run one system. You want to have 20 system, 100 system run by one blue collar. And this exactly, these are real world problems, line integration, quality assurance, that kind of stuff that really contributes significantly to the success of the entire AM, what we call manufacturing route, from the design model up to the finished and good. And additive, it is just one process step. So there's always finished machining in there. There's always quality assurance. You need to get rid of the powder. You might be carrying out any kind of heat treatment. So that's why we say additive for us is the entire end-to-end manufacturing route, rather than being just a process step.
When you look at the challenges you had maybe not 25 years ago, but 10 years ago, how did the challenges shifted in these times?
Yeah, in the beginning it was really about, hey, can we process material A, material B? We started with stainless steel, then we talked about titanium alloys, high temperature nickel-based alloys, etc. And then, of course, all the other surrounding and environmental things came, right? Hey, how do we get rid of the powder? How can we get rid of the base platform, etc. And 10 years ago, I mean, in the year 2016, 9 years ago, we, as at that point in time, being with Siemens PG, we acquired Material Solutions in Worcester in England. And for us, it was a kind of M&A. It was a merger and acquisition. And that was a really horror story for the first 2 years, because that was an SME. That was a small enterprise operating 25 printers. And you come with an entire Siemens PG, right, run by SAP and all that kind of stuff, and really integrating a small size enterprise into a large AG when it comes to ERP systems, SAP and that kind of stuff. That's a pure horror. And so, but these are real world problems, right? This is exactly the step of upscaling things. And yeah, this is exactly 9-10 years ago.
Mm-hmm.
Yeah.
Avid, do you remember challenges in the beginning where there's no need to think about today, and which are the newer challenges you face today?
So I think we are still with a little bit of the same challenges like 10 years ago. I think, Michael, you mentioned it. So everybody's talking about the application.
Mm-hmm.
So if I'm coming to a supplier and said, okay, can you print me this part, please, out of stainless steel? Every time they ask, okay, how should we print it? What is it for? What is the application? How do we want to qualify it? And so on and so on. And every time it develops to a small research project. And I just said, okay, no, I just want a stainless steel. Do you have a material data for me, the material data? And please provide me the best quality which you can. And every time you're talking with the people and you have a lot of small research projects with different suppliers, because not every supplier has every material in-house. And this is in the moment the same. So to find an application, to qualify it for our own, because we are in the railway industry. I know how do I qualify this part. And I will not educate a supplier what a rail industry is, because it's too big to educate him. And yeah, I think that's the challenge, because I just need maybe 2 days to find an application, to qualify it, and then I just want to purchase it. And then it's about 2 weeks, 3 weeks, and we promise, okay, we want to be fast, but we are not as fast as we might think. Mm-hmm. Because if you are asking it a producer with a conventional manufacturing, milling, you just say to him, okay, I need this part, this geometry out of stainless steel, and he says, okay, you got it, 1 week, here you go. Mm-hmm. And this is, I think, the problem in the moment, which we still have, which was 10 years ago the same. And also the thing of, you mentioned also education. We have to educate also our designers. Stephanie mentioned it, we are now only just, I like to say, copycats. We are just taking an old part and reproducing it and don't change the geometry. And for additive manufacturing, it's a challenge, because everybody's talking about lightweight. We can have here less material and so on, and we don't need it. So in our industry, we want to develop there, but in the moment we don't need it. And I think this discussions and to educate. So we have also to educate the 3D printing industry how a regulated industry is working, and how our, let's say, our guidelines are for quality and what these companies have to fulfill. And I think we missed in the last 10 years the step to develop really good processes, norms, and standards, so that additive manufacturing is not an innovation anymore. That additive manufacturing is like conventional production, and for me, additive manufacturing is a conventional production. It's not a versus. It has to add up with milling, with casting, and so on. Yeah.
So, as Arvid mentioned, he's not using all the advantages. Michael, I would like to know from you, when you observe your visitors and clicks on your website, for example, do you have an impression which of the multiple advantages of additive are of most of interesting for the audience? Because there is lightweight, there is using different materials, there is maybe a shiny structure or appearance, or the faster supply. So we have so many advantages. Do you have an idea which is of most of interested?
I mean, that's not something our analytics actually reveal on user data, how people are arriving at the site with what's in their mind in terms of the advantages of additive. We can't really say anything based on the analytics data there. I suppose what we can maybe talk about here is verticals. So we've been running an event focused on aerospace, space and defense for a number of years now. And the traction on that over those years has ramped up massively. We've done something similar in the energy sector, the automotive and mobility sector, and the medical and dental sectors. So we're now seeing people who are not sort of necessarily sort of additive first people. These people are manufacturers, or maybe they are the domain experts in additive in a much larger organization. So we're seeing that spread beyond, the people who will come to Frankfurt for the week, who will know everybody, and we'll all see each other in Champions Bar, afterwards, or we'll be all at the booth parties. And it's the people you see, Terry and I were in Lyon recently together, and I've been at lots of events where you see the same people. But I think those verticals where they don't necessarily have that network already, that's what we're seeing. And you'd be surprised. You asked about the advantages of additive they're most interested in. Remarkably, it's not the real sort of frontier stuff, the sort of shape memory alloys, or the sort of beam shaping, or sort of even talking about wild things like 4D printing or volumetric. This is stuff that people were talking about 10 years ago, and they're going, very fundamental advantages of additive that people are just coming to now, and it feels a bit Groundhog Day sometimes when you've been doing it for a while. But hey, if that's what actually works, it doesn't have to be flashy, right? I think, as Arvid, you were talking a bit about, sort of AM is not innovative anymore. Well, if you're looking to scale your product, do you really want to be the first person to do it? Do you want to be really sort of pushing the envelope, breaking the paradigm, whatever buzzword bingo I want to drop in there? You probably want something that's a bit more reliable, but you can sort of sort of go, this is going to be working today, the same way it works yesterday. Yeah. You want it to be boring, you want it to be predictable. What was the old saying? No one ever got fired for buying IBM, right? So there wasn't innovation, and that's the kind of mindset you're dealing with. People want to take a substantial CapEx decision, and they want advantages, but they don't want to be fired at the end of the day, right?
Okay.
I also want to pick up quickly on something Ingemar mentioned, the interoperability.
Sure.
So I was at a pre-event event yesterday, probably some of you at the SLM event, and I mean, there are a couple of telling things there. I've not had a chance to look around the various halls here, but I suspect it's going to be a similar theme. Big presentation highlighted with tech insights, and the tech insights SLM were describing were all around their software, SLM Prep. And they illustrated this with a sign. Now, whether this was me reading too much into it, but on the sign, it was a crossroads, and it was software and hardware. I think, and I'm going to try to validate that this week, that that's where we are. I wouldn't say machines are a commodity yet, but it's the things we can unlock from them with the software advances, which are going to be shaping the next decade of additive. I think that interoperability point you made is really solid. That's something people are starting to focus on a lot more, integrators, and there's a lot more machines talking to each other and what we can do with that data. That becomes very interesting, you know, for strategy and also for who owns the value when we start getting to that stage.
We are getting to the situation today, and right now you mentioned it in your presentation earlier. We have tough times. What is your assessment, Terry, about the situation, the economical situation right now? Could you give us your insight about where in the world, US, Europe, China is going what on? So is it equal, or maybe you give us some short insights here, and then I come later back to Michael. Ask me again. I don't want to forget, because I read your article. And I want you to dive into that topic again. But first, Terry, what is your assessment about the economy situation right now?
Yeah, it's still difficult, but I'm seeing signs where investment's coming back. You know, companies can't stop investing forever, right? And I'm talking about not only the investment community like private equity and venture capital, but also companies investing in new machines, upgrades, that sort of thing. And we're beginning to see that.
Are these already replacement investment, or do you know that from your numbers, or is it an investment into new businesses?
Well, we're seeing companies in general begin to look at new investments.
Okay. So
both
you don't know if replacements.
Well, we don't have any quantitative data. It's all been anecdotal to this point. We just, you know, haven't had a business reason to dig at that level at this particular time. Leading up to Woolage Report 2026, we may have some of that, but that's still out a bit. So
I'm looking forward to this.
Yeah. So, but no, I think it's looking up. It really is. I'm more optimistic. I'm an optimist in general. I'm also realistic. You know, I don't like to create hype or help promote it. I like to, but at the same time, I always have I try to have a positive outlook on, you know, things. I mean, there's always peaks and valleys in the industrial sector, no matter whether it's computing or some other area. But you got to look at the overall trend. Yeah, it may be a valley, but overall, it's been you know, growing 18% the last 10 years on average. Not bad.
Ingo, from your perspective, you are working a lot with companies, and tough times, I think, for an institute as well. What is your assessment here, and look into the future maybe?
I mean, we are a German institute, right? And we do live in a consecutive year, 4 years in a row of recession. So this is really a tough time. But also, I'm an optimist, definitely like Terry. I mean, we know each other for I don't know how many years. We are both optimists. And I would like to provide two examples. One of the B2C arena and one of the B2B arena, where you can see that it makes significant sense really to, in the end, look at AM. One is a company located and stationed in Hamburg. It's called Zellerfeld. They operate at the moment 200 printers, and they do print in the B2C arena, so consumer goods, sport shoes, sneakers, entire shoes, not just the sole, entire shoes. And they are right now investing in all 5,000 printers. 2,000 in Hamburg, 3,000 in Austin in Texas, because the biggest market for them is the United States. So upscaling consumer goods, sneakers, sport shoes. Good idea, right? So you see Peter Thiel is investing into Zellerfeld from the Bay Area. So it couldn't be, or it could be worse, Terry, right?
Right.
It could be worse, just to add on yesterday's night. And the other one is B2B. Providing one example, and they see that it makes sense, where AM is a manufacturing key enabler for the next generation product portfolio. If we all talk about green energy, if we all talk about electrolyzers, hydrogen, etc., you can also think in re-electrification of hydrogen, and you do that via gas turbines. And of course, you can fire hydrogen in a gas turbine. The bad thing is a disadvantage, because hydrogen does burn with 200 Kelvin, 200 degrees centigrade, higher temperatures in comparison to natural gas. So what you do is you remelt the entire gas turbine in 10 minutes. For 10 minutes, you do generate power, electric power. Congratulations. But after that 10 minutes, done. You can re-engineer the entire hot gas path. So combustor components, burner components, and the first and second stage high pressure turbine. Done. CAD model, done. Problem is, they are so fine, narrow, hollow structures, cooling channels needed in these new components for an H2-ready gas turbine, that these parts cannot be manufactured by a cast route any longer. So that means, but you can print out these parts. That means that an H2-ready gas turbine for the future, to re-electrify hydrogen into electric power, to convert hydrogen into electric power, is just possible with additive manufacturing components. And this is, I mean, this is definitely a huge step forward, right? Because otherwise, without AM, you would not have an H2-ready gas turbine. That's it, full stop.
Mm-hmm. And from a technology view, do you assess new approaches which could be very helpful for the industry? At least you're at the forefront of research.
Yeah, I mean, we are in the material game, of course, in the material systems game, of course. And by also, if you look at the entire manufacturing route, what I said before, AM is just one process step. And if you have a look at the entire time for the manufacturing of a component X and also the correlated cost, AM for these very specific products in these kind of vanes, blades, combustor parts, the AM process step is just 5% of the entire cost. 95% of the entire cost are generated usually in the post and finish machining, right? So you do have to do it either way, but there is no single alternative given, because these parts cannot be manufactured via casting. That's the point. Mm-hmm. And so you see AM, yeah, you can use AM or not, and you can optimize the 3D printing process, increasing the deposition rate, but then you optimize just 5% and not the 95% in the post and finish machining. And this is exactly what we do. That's why I always try to really to put a focus on the entire end-to-end manufacturing route, because you need to optimize the entire route holistically and not just process step for process step.
To get faster to the results, right? Michael, I mentioned, I remembered your article, and I want to bring your perspective. Ingo already said, you know, you have to look at the successes and the success stories, and that's one way to go or to work with an economy situation like what we face right now. But in your article, you had a very nice way of thinking. I want you to give us an insight. When you are asked about the economical tough moments right now, what is your answer then?
Sorry, which article?
There was an article. I don't know the headline anymore, but when I read it, you had a shift of focus away from problems to the solutions and to the future. And I wanted to repeat it here on stage for our audience. What is important for you when you're talking about the problems or the challenges the industry has right now?
I mean, I think, you know, Ingemar captured it sort of very simply, right? You know, I think that stat there was at 95%. You mentioned that the cost isn't sort of, you know, what goes on in the additive part. It's the additional touches on that part after it comes out. You know, we're looking at Zellerfeld with something like, was it 5,000 machines you mentioned? You know, okay, well, look, I mean, I don't know what machines they're buying. I'm sure they're sort of very high quality, but you know, we've got about 30 machines in our office, and you know, stuff goes wrong with them. You need to tighten the belts. You know, you need to clean these things. You need to actually maintain them. These all take, you know, sort of at the moment, sort of ChatGPT can't do this for you. You know, you've got to get there, get the sort of the actual sort of, you know, the old get into meat space and do it. It's not a sort of type of thing. When you go to that scale where you're operating, you know, sort of 3,000 machines on one continent, 2,000 on another, that's a technician, many technicians' jobs there. And I think that's where the challenges are still, right? It's the integration. So I think, yeah, you captured that very well, so I don't really want to go over that too much. I think there were a couple of articles I wrote recently, sort of ahead of Formnext. One which was on the sort of, I think as I put it, the industrialization of imagination, right? So we go back. That's the one you're thinking of, great. So in that article, I was trying to talk a bit about those days when everyone would come on stage and we'd have 3D printing evangelists, people used to call themselves, right? And someone would be talking about, well, you know, we're going to be 3D printing food, or we're going to be sort of, you know, sort of putting a microwave on Mars, and that will sort of terraform the planet. You know, we sometimes, in a derogative manner, I have to point out, call that the replicator paradox. The fact that sometimes you think you can do everything, so you do nothing. You know, replicator obviously tying back to Star Trek, also tying back to some of the early desktop world. It's like, let's do everything. Now that becomes a way to quickly spend a lot of money, employ a lot of people, and go in 100 different directions at once. Let's see how that goes. I think we've seen how that goes for a few companies which aren't here anymore. And we need vision. We do need vision, don't get me wrong. I think in the main, I'm with the other guys on this panel, I'm in the glass half full category. I am an optimist. But we need reality as well. And I think, you know, amongst us, everyone's also got their feet on the ground. So that industrialization of imagination, that's going from those visions and what it takes to make it a reality, what it takes to start doing, you know, doing something at scale, whether it's 3D printing sausages on Mars or whatever sort of activity you're up to.
Yeah, thank you for sharing these thoughts. You brought it very good to the stage. What the impression was from your article. Yeah, maybe we are already in the future with your answers, but I want to be clear in the future. Let's talk about the next 10 years of additive manufacturing. Maybe, Arvid, what are your goals, and what do you want to reach with additive manufacturing? Where want you to be? Just printing instead of 200,000, 400,000? Is it the only goal you have, or do you have next steps in your vision?
We have next steps, but I have to make then a callback to the past, and then I will go to the future. Because we have printed now, let's say, 1,000 different use cases, 200,000 times, and have saved in the last 5 years 25 million of euros for the German railway company. And our goal is to accelerate this. We needed 10 years for it, for these parts and for the effects. And in the next 5 years, we don't want just to double it or to make the same again. We want to multiply that and to have potentials or effects or savings of 100 million euros. Because Stephanie and I, we know that this potential is in our company there. And this is how we are now looking on this topic, additive manufacturing, more from the economic side, and thinking, okay, how can we make this? Of course, you can say, okay, I have this challenge. I want to now have more effect. I want to have 4 times more. So now I need 4 times more people. And we just take people from them into a department and say, just work and let's save this money. But we are thinking about, okay, how can we make it with just a few more people? How can we maybe automate processes? How can we have better standards? How can we educate people so that we don't have to make the whole work every time as a small governance department, maybe to decentralize this knowledge which we have in the whole company. and to accelerate this hockey stick and to gain more and more use cases, and also to have a look on which solutions do we needed 5 years ago and 6 years ago, which weren't on the market in a moment, and which are maybe in the future on the market, so we can use this technology now and talk with machine manufacturers, talk with R&D, what do we need in the future. And this will be maybe, I think, for us, of course, a positive way in the next 10 years. I don't want to say how much we want to print, because maybe I will find one part which is worth 50 million. Maybe I have a lucky, but I think it will be a lot of parts. Yeah.
Okay. Yeah, maybe we're running to an end, but let's have a final reflection or kind of closing. When I think about the future, I think about young people joining here or the exhibition. And let's have a look in our mind to them. If you could give one piece of advice to the next generation, Terry, to the next generation of engineers, for example, or entrepreneurs entering the field of additive manufacturing, what advice would that be? So what should they focus on, or what mindset should they bring in with? So I want you to give us an answer. You're seeing the numbers are running yellow here, so we have not so much time left, but short answer, what would be this aspect you want a young engineer?
Sure, I'm happy to do that, Frank. And if I could just build a little bit on this last question. So Bill Gates once said, and I'll paraphrase that, we tend to underestimate what's going to happen in 4 to 5 years. I'm sorry, we overestimate what's going to happen in 4 to 5 years. We underestimate what's going to happen in 8 to 10 years. So thinking about that for a moment, you know, these young people will be around, maybe they're going to be at the middle of their career in 10 years from now. You think about the role that AI could play. And you mentioned how design was a bit of a problem. Your engineers are, maybe not designing to the degree that they could be for additive manufacturing, right? Is that accurate?
That's true.
Yeah. So think about the AI tools that will be available in 8 to 10 years from now that can help with designs. These designs will help drive entirely new applications, which will drive the growth. And so that's exciting. I hope I'm still alive at that time, because I want to see that. I may not be sitting here in 10 years, maybe, who knows, but I want to see that, because I think it's really exciting how AI-driven software tools will help drive these new designs, because not everything is possible, but almost. I mean, as far as new ideas. And I would encourage the young people to get out there and try new things. And to be realistic, but to also experiment and play and come up with entirely new ways of thinking.
Okay, AMIT, what would be your piece of advice?
I think you already mentioned it as you had the question. I would say focus also. Focus on one topic. Also, if you want to start with 3D printing, don't try to use every manufacturing method and so on, and every manufacturer. Just focus on one point, and focus maybe also if you want to start a business as an engineer, young engineer. Don't try to say, okay, I want to go in automotive, in rail, in space, to the sea and so on. Just focus on one point and focus on what you can do and make this really good. Because we have seen a lot of promises in the last years, because people have not focused. They have promised bright applications and bright machine and materials, and I would advise just focus on one point.
Okay, thank you. Michael.
I really like this question. I was asked a version of it a few years ago at an event I was speaking at in Oxford, and my daughter was in the audience. And so she may watch the replay of this, so I can get to give the same answer to her. I can't embarrass her IRL as I did then. But Vanessa,
talk to camera too.
Read more books.
Thank you. Ingo, what would be your piece of advice for the young ones?
Not advice, but I would encourage really the next generation really by saying, dare to fail. Really dare to fail, because if you fail, yeah, that's okay. And be not afraid of failing. but stand up and really learn fast, fail fast, learn fast, because if you learn faster than others, then you're better than others. So it's really dare to fail. It's okay to fail.
Perfect.
Amen. So
yeah, amen. So listen. What we have to say. Yeah, thank you very much for your insights, for your advices, for your examples, and for bringing your experience here on stage into the family. So it was very good to have you here, and I hope you will have a successful fair. The 4 days are lying before us. So my advice for you: make use of it. And I'm very happy that we have our audience here. And thank you very much for watching our live stream at home at the screens. We will have a short break here. And this afternoon we will follow up with our Pitch Next event that will be very much a highlight. And there will be a ceremony, a signing ceremony this afternoon, later this afternoon. So make sure to zoom in again and to have a look at the signing ceremony. Which companies are involved will be revealed then. So we're happy to have you on stream and happy to have you back after our midnight, our lunchtime break. Thank you very much and see you later.
Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. Cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials for car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special. Something specific. Specific industries.
Aviation aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and, of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
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 Awesome. That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning, now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in a breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skates out tonight. I'm gonna go out and have a good time.
Hello, ladies and gentlemen, and welcome back here at the industry stage at Formnext 2025. I hope you all had a wonderful start into this trade show. We had a very strong and inspiring morning where we learned how our industry has developed, where additive manufacturing stands today, and how Formnext has grown into one of the most important platforms of AM worldwide. And now it's time to look ahead. And the best way to do so is with the next generation of innovators. And this is exactly what PitchNext is all about. From the very beginning, Formnext has made one thing crystal clear. Startups are not a side program here. They are an essential part of the future of our industry. In order to support them, Formnext created the startup area here in Hall 11D62 right next to our stage. And it offers a newly founded companies an affordable participation package so they can join the global AM community here in Frankfurt to show their work to investors, partners, and of course, potential customers. And to make sure we really have young companies pitching here at PitchNext, the startup area follows clear criteria. They have to be founded less than 5 years ago. Their annual revenue should not exceed 10 million euros, and there should be no majority ownership by a big company. We also are joined today by startups from the BMWK Young Innovators area, supported by the German Federal Ministry of Economic Affairs and Climate Action. Before we move into the pitches, let me highlight something very, very important, and those are the Formnext Awards. And the awards have grown even further this year with 6 categories: the Sustainability Award, the Design Award, Revolution Award, A-Ambassador Award, Startup Award, and the Rookie Award, celebrating sustainability, design, groundbreaking new technologies, and outstanding newcomers. And what is special, you, the audience, help decide the winners. So your vote counts as an additional juror's voice and can make a real difference for those young companies. So please vote. You can go over there to the Formnext Award stand over there, check the awards, so the award participant out, and give your vote online for them. So how does PitchNext work today? We have basically 3 pitching groups today. We have young innovators, then we have startup area and startup award finalists, and finally rookie award finalists. Each pitch lasts 3 minutes and 30 seconds, followed by 1 minute and 30 seconds for your questions. And even as I am the nasty timekeeper, you can imagine I cut them off directly after the 3 minutes, 30 seconds. I highly encourage you to ask questions afterwards or give feedback, because this helps them a lot and is quite important for them to experience that. So you will see new ideas in materials, software, medical application, automation, process optimization, sustainability, and completely new business models. These are the ideas that might shape the next decade of our additive manufacturing industry. So please have in mind, for many of these startups, PitchNext is their first international big stage where they present their solution. So your questions, your feedback, your support, and of course your votes for the Formnext Award can help them take the next steps on their journey as a company. And with that, let's begin with our first category, the young innovators. Sometimes innovation comes with rethinking something very traditional, like metal casting, for example. Our next startup shows how you can turn a simple 3D printed pattern into a fully functional aluminum part right on your desk. It's a new way to prototype metal parts without large industrial setups, and it opens the door to fast, flexible development in many, many industries. And I'm happy to announce my first speaker, and I ask you for a big round of applause for Christoph Rehkamp, who is CEO of Automas. Automas, bitteschön.
Okay, thanks for the introduction. I'm Christoph, and together with my colleague Felix, I founded Aratis. And with Aratis, we enable everybody of you to create metal parts right at your desk. So this is our machine. You can see it here right on a regular desk. And it's really that easy. You can create metal parts in less than 24 hours. Thanks to the automated process, you just need 30 to 45 minutes of manual working time. It's a desktop device, so no specific infrastructure is required besides a normal power outlet. And as it's easy to use, it's accessible to everybody. So if you can handle a filament or resin printer, you have all the skills it requires to use our machine. So how does it work? The whole process is based on casting. So we first start with a polymer part as a pattern that is converted into metal using our machine. Besides technical and massive parts, also very filigree parts are possible, like you see on this micro benchy and on a scanning electron microscope image on the right. Also, flexible structures are possible. Here is an example of flexible robotic gripper made of AA7075 aluminum. Now I will guide you through the process step by step. As I mentioned, we start with a plastic pattern. You see it on the left. This can be printed either with a filament printer or a resin printer. As in the next step, we attach a wax sprue. Just use a soldering iron, heat the sprue, and attach it to the part. This will guide as an inlet for the molten metal later during casting. The next step is the mold creation. So for the casting, we need a mold. For this, we have also developed a process that allows this to be done without any dust right at your desk. So our investment material is pre-packaged in water-soluble bags. You just add water, the bag dissolves, you shake it briefly, and pour it around the plastic part. After 30 to 40 minutes, the mold is set and can be taken out of the container and placed right into the machine, as you can see on the right side. So the mold has placed in the lower compartment in the kiln where the pattern gets burned out later during the process. You then load the crucible of the machine, which is located at the top side, with raw aluminum, for example, or any alloy you would like to cast. The material shape doesn't matter, and it gets molten anyway, so no specific shape like powder or wire is needed, just any scrap metal does it. You close the doors, select the appropriate alloy from our process parameter table, and hit the start button, and the machine does the rest. After cool down, you can take out the mold, crack it open, and you have your finished metal parts right at your desk. So that's it from my side. If you're interested in our machine, we have a booth in Hall 12.1 at booth B39A. Feel free to come by, see our machine live on the desk, and step into detail in the process. Thanks.
That was one of the best timekeepings I've ever seen, Christoph.
Bit too short, but...
So, I mean, you presented the solution. Let me ask the first question first, and then, of course, we invite the audience. What types of applications or parts benefit most of your desktop metal solution?
So we mainly think of small and medium enterprises that might not have the capacities to use a large metal manufacturing machine. So they can just put this next to their FDM or SLA printer and do it right in their office without any extra infrastructure for an economic prototype production.
Very good. So before I ask you the next question, first in the audience, please feel free to raise your hand. Probably you have to shout if you're on the right because I can't see you. So feel free to ask any question. So are there already applications you can mention where your solution has already been used?
Yeah, we also sold some machines already, so they are mainly used for prototyping as well for small serious parts for real use, like specific machines where you just have like 5 or 10 machines per year. But also for serious production, the casting process is pretty suitable. So our machine, of course, runs one cycle in about 18 hours. So for serious production, you could just ask an external investment casting provider or switch to die casting for high volume applications. So that's also an approach for high volume.
And the question that is always asked if you come up with a new technology out of AM, how's the quality compared to a traditional casted part?
Yeah, the quality is basically, it is traditional investment casting like. So as you maybe saw on the mini benchy, if the pattern is in good quality, we just have a one-to-one copy out of metal. So it depends only on the plastic pattern that you create, and you get a one-to-one replication out of metal.
Awesome, very good, Christoph. Are you at the startup area as well, or?
No, we're just upstairs in the BMWK Young Innovators area. So 12.1 B39.
Yeah. So you just heard it. Please feel free to join Christoph at his booth and ask further questions. Thank you so much, Christoph. Big applause for you. And Aratis, thank you so much.
Thank you.
So I like the next one really, because in additive manufacturing, waste is one of the big hidden problems. So we're talking about empty spools, failed prints, support material, all that stuff, and most of it ends up in the trash. But what if we can turn this waste into new high-quality filament, for example? So Recycling Fabric does exactly that. They collect and process selected 3D printing waste, shred it and turn it into industrial-grade recycled filament on 3 production lines. And probably I did already the pitch, I hope not. So please welcome Rudolf Leuer, who is CEO of Recycling Fabric. Rudolf, stage is yours.
Thank you very much for the introduction. It's the third time for me being here to present what we do at Recycling Fabric. And I love to talk about waste, and especially waste in 3D printing processes and what we can do with it. Because plastic is such a great material. We can recycle it multiple times, it lasts really long, and often it gets stored somewhere in dirty places. But that's a big mistake we already do somewhere in the world. Just throw everything together and build a big pile of waste. Garbage that never will be recycled or, in best case, getting burned to gain the energy. So we decided to put the customer into place to help recycling materials that we ever will lost. So we have a full recycling cycle from waste to product in Germany and now also in Turkey. We are expanding our production, and if someone of you is looking for a partner to join Turkish market, then visit our booth. But the problem we noticed is everywhere the same. We have a linear process where the waste has an end of its life. The plastic is then lost forever. And the most conventional recycling or waste management systems have no idea what or how they can change to save our resources. And there are several solutions on the market with desktop extrusion systems that are maybe not that good working, low output. There's this open source Precious Plastic where you can do something else with the plastic. Also, maybe some of you know the videos where you can melt down your plastic waste in some silicone forms and do some sketchy shit in your back oven to get skulls you can put in your window. And then we have this normal industry, that conventional industry that is not really recycling. So we have a full circular economy in 3D printing, from collecting the waste, putting this waste back into a waste stream where we are shredding it, sorting it, extruding again to 3D printing filament. And it's working due to a reward system where we give the customer points they can use as a discount for their new filament. And even with this whole cycle, with the transport and so on, we save up to, no, not up to, minimum 53% carbon fiber footprint. And new material is used. So in the future, it's getting more and more important to build up more factories to recycle more material. We have done a lot of stuff in the last years and also have some new products, and we established a new company in Turkey. So thank you for listening. Visit us in hall 12.1 and it's booth B93D.
Very good. Excellent. Big applause, ladies and gentlemen. A really, really good topic. So let me ask you the following question. As I'm myself user of filament, so if it comes to quality, I remember there was a project of Adidas that wanted to collect plastic from the ocean and reuse it. And due to the different sources of waste, there was a quality that was not reusable anymore. How do you ensure that you can use the quality afterwards?
It depends what you want to do with the waste after you collect it. So we decided to make again filament out of it. So in the beginning of sourcing the waste, we have a look at the quality. Is it the material we can reuse and recycle into high quality 3D printing filament? Because we have such high standards, even in recycling, that the diameter, there is no chance of any contaminants that could clog the nozzles or something like that. It has to be perfect and on the same level as new material.
So how do you sort it? You have PLA, PETG, whatever that is. So there's so many materials. So do you sort it up front, or how do you know what kind of source it is, basically?
The customer knows. So the customer knows where the material came from. So we can source materials from hospitals like PETG blister packaging that we can use again in PETG filament, or from some food packaging, PLA. Yeah, as well.
Very good, very good. Very good initiative, very good startup. Big applause, ladies and gentlemen. Rudolf from Recycling Fabrik, thank you so much.
Thank you.
So the thing is, if you're doing additive manufacturing, it has one problem. It creates an enormous amount of data from the machine, from the material, the environment, and quality inspections. But in many companies, this data stays disconnected. This is something what we could see the last years. So AMSite wants to change that. AMSite offers a holistic platform that captures, links, and analyzes every step of the AM process. So, in my opinion, it's a powerful step toward reliable, scalable industrial AM. And please welcome Tim Wischerhoff, who is CEO of AMSite. Please, Tim.
So, who of you knows this building? Raise your hand. So those who don't, it's the iconic Elbphilharmonie in my hometown in Hamburg. It opened end of 2016. However, it was until end of last year that it was the first time I actually managed to go there to enjoy a concert. I have to say I'm not really into classical music, so I went there more for the experience of having heard a concert on the concert hall than for the piece of music itself. However, I was surprised how much I was impressed by the orchestra afterwards. I couldn't really figure out why that was the case until a few days later. I realized it was because they managed to put a complex piece of music, classical music, into a way that they performed it, that it was easy to enjoy for somebody who's not an expert in that field. And there's always something that fascinates me. If there's a way to put complex things in a way that they're easy to enjoy and to follow. And again, a few days later, I realized this is also the reason I spent my whole life in industrial 3D print, my whole life of professional career in industrial 3D printing, because it's quite similar, right? The idea of 3D printing is the most simple way how you can produce a part. You have a machine, you push on a button, and a few hours later, you have any shape you want to have. It couldn't be any simpler. But behind that, there's a really high complexity. If you go to powder bed additive manufacturing, we have over 150 parameters that influence the quality of a part. These are parameters such as the quality of the powder, the process parameters that you use, or the environmental conditions such as humidity or temperature in the manufacturing hall. And to produce a part of high quality, you need to match all of these parameters to put the part in the right quality. And many of these parameters change over time. So speaking of the picture of this orchestra, it's a little bit like if you are responsible for the processes, for your additive manufacturing processes, it's like you have your environmental guys, you have your powder guys, your post-processing guys, your laser guys, and you consistently need to manage all of these together. It's very complex. And I spent many years of research trying to find out how can we effectively manage this complexity in additive manufacturing. The only way that consistently worked is a data-driven approach. And we couldn't find a tool that actually helps you to do that, which is why 2.5 years ago we founded AMSite to do exactly that. is software that helps you to develop, qualify, and optimize additive manufacturing process based on the actual data that you collect in your manufacturing hall. So how does our software work? We automatically collect all quality relevant data, such as material data, machine data, quality data, and bring all of these data into one single database. So if you're producing high quality parts, you usually probably already have this data, but in 10 different Excel sheets on 10 different share folders, and we have all of this information in one software platform now, which makes it easy to, first of all, prove the conformity of the part against the specification that you might have, but also use the data to optimize your processes in terms of quality and cost, for example, by statistical process control. So if you're producing high quality parts in AM, I think there's two ways. Either you find a high class conductor for your processes, there are only a few out there and they are super expensive, or you use a software such as AMIT that helps you to do that for you. So thank you very much.
Awesome, Tim. Thank you so much. Awesome. So first question to the audience. Any question? Tim's side? I have, of course, some questions, Tim. You can't get away without my question.
I know.
So what I really like about such solution is what is the business proposal? What is the business profit out of it? So if you mentioned different dimensions where the customer can take a profit out. What is the biggest one? What is the biggest focus where you see the advantage of the solution? Is it quality? Is it...
It's that you can actually make decisions based on data, not gut feeling, right? If you, for example, having a problem in your manufacturing and don't know where is it coming from, is it from the powder, is it the machine that makes the problem, you really have the tool now to understand that really fast, to do the root cause analysis and find the error and the what might optimize your process very easy. Or optimize your processes in terms of quality and cost, make really data-driven decisions. I think that's the biggest benefit you have.
And very important question, once you want to implement such things, everybody is concerned, how difficult is it to implement? How difficult is it to implement?
Obviously, super easy. I mean,
of course.
I want to be honest, obviously, for each software that you want to learn, there's a learning curve in the beginning, so you need the training and need to adopt to the software, which probably takes 2-3 weeks, but after that, you should be all set up to use the software. Yeah.
Awesome. Thank you so much, Tim Bishop, AMIT. Ladies and gentlemen, big applause for Tim. So now we come to a topic that I faced myself already, and it's quite important, in my opinion at least, because one of the biggest challenges in our industry is turning exciting AM technologies into reliable, scalable production. And that requires one thing above all, and I needed to learn that the hard way on myself, is qualification you can trust. Our next presenter is working exactly at this intersection, so helping companies move from innovation to industrial readiness. And please welcome Gregor Reischle, CEO and founder of Qualified AM. Gregor, stage is yours.
So welcome, I'm Gregor Reischle, founder of Qualified AM. And we qualify AM on scale. That's new. At this Formnext, we just launched our software. And the software empowers everybody, which is sitting here and in front of this video, to start his own qualification project based on today's known standard. It was not available till today. We just launched today at this Formnext the software which empowers every technician and every engineer to do that on scale. How this works, the entire industry speaks since years at each conference how to qualify, how to manage parts in regulated industries. And they discuss and they are blaming each other that there are no standards and the certifiers is not capable to certify. They know how to. Or some of them even prevent, we don't want it. The market of AM is today just so minimal in comparison to other technologies. Everybody of us knows that. So we are changing it from now on that every engineer can go to our site, qualifiedam.com. He can install Quamix software and start qualify projects. We have a proof of concept. We are actually exclusively certifying for ASML's supply chain, which is European leading manufacturer of semiconductor equipment, and their additive manufacturing parts are qualified via qualification system. Same for the railway, same for many other regulated industries like hospitals. So we have the proof of concept in the industry that our system works. What are the next steps? The next steps for our industry is that every engineer starts to communicate, I know what needs to be done. How they can do that? They install QuamX software, they load up their parts, they load up their equipment, they load up their materials, what they would like to qualify, and start to use the software and communicate to his neighborhood, I am empowered to qualify additive manufacturing on scale. What kind of problem are we solving? We are solving risk assessments, which are usually dedicated to very highly experts, which are risk assessment experts. Usually those people don't know nothing about AM. These are these gray-haired people which are sitting in a room and doing risk assessments for a couple of months and years. We are changing this, empowering every engineer using our software to risk assess based on standards because it's in the software already implemented. We empower with AI the speed of risk assessment and of course with SPC data which we validate, which is fed into the software. So we have a straight line of qualification. We have 4 modules. One module is for free. That's for every supply chain owner. You can download it our landing page for free and can use the qualified supply chain. We have the risk assessment model, the QMS model, where you build up your quality management at scale. So basically you can qualify your printer, your materials and processes at scale with the software. And the QuamZ module, where you report the data back to us, so we issue a certificate for your material, system and process. What else? This is the market. For us, we see the market 50 till 100 million in 5 years. The first million we are targeting next year, which is visible now with the software, and of course with your commitment to start to use and qualify our industry, because only together we grow. Thank you. Please visit our booth. We are in hall 12.1 B39B booth, qualifiedam.com. You can see our projects there, download the software for free, start for free, and then go from there. Thank you.
Thank you very much, Gregor. Sorry, I didn't want to interrupt you, but you run over time.
Yeah, I know.
Presentation, by the way. So one question that I really have is that came up during your presentation. You showed how you shortened the time, so 20 times faster, that was one thing. But is there a restriction in terms of a certain kind of material or a certain kind of machine using your software?
Yeah.
Because is it only, let's say, is it only based for several technologies, or is it open wide for AM in general?
Yeah. Excellent question. So the standards which we write and define are for our industry, and we want to see our industry grow. And the industry means all process categories. Well, of course, we are starting with powder bed fusion, DED. These are the most industrial processes, but we have already first project qualifying MAX printers, FFF technology in serial application. Deutsche Bahn is using FFF. Yeah, hospitals are using MAX FFF printers. So yes, and we use that in our software. But you still need to know where your risks are if you use a new printer. So every innovative company need to install the software and put up their risks inside, and then the technology scales.
Awesome. Thank you so much, Gregor.
Oh,
Big applause for you, ladies and gentlemen. Gregor Reichle, qualified AM. So these were our first 4 pitches. There are a lot more to come. Before we go into the second round of our pitches, you can enjoy a few minutes of Formnext highlights, and I see you back here in 5 minutes. Thank you so much.
Alonic is revolutionizing robotics manufacturing with 3D tissue braiding, a world-first technology that grows complex, movable robot bodies directly from functional fabrics, using a seamless software-hardware platform the company enables automated creation of flexible robotic structures, arms, fingers, and joints without assembly. By embedding elastic fibers, sensors, and wiring within a single 3D textile form, Alonic reduces costs, speeds up prototyping, and redefines how machines come to life. This is soft robotics, engineered with precision, where design meets biology, and the next generation of human-safe automation begins. Biomotion is transforming life sciences with industrial-grade 3D bioprinting, making it as reliable and accessible as modern manufacturing. Their high-precision platform integrates automated parameter control and intelligent supervision to ensure reproducible results. Every single print, every single time. This innovation empowers pharmaceutical and biotech companies to replace traditional 2D cell cultures with 3D human tissue models, accelerating drug discovery while eliminating the need for animal testing. By bridging biology and industry, Biomotion is enabling scalable, ethical, and data-driven medical research for the next generation of therapies. Nurio is unlocking new speed and creativity in engineering design. Their AI-driven 3D software tools automate repetitive CAD tasks and generate production-ready designs for additive manufacturing within minutes. By capturing expert logic into code, Nurio's plugins and online configurators drastically reduce design cycles, improve manufacturability, and cut costs. From aerospace to tooling, they are helping engineers move from manual modeling to intelligent automation, transforming the design process from constraint to catalyst. OIO Labs combines AI, 3D printing, and bioresorbable materials to create personalized implants that heal naturally within the body. Their OIO Vision and OIO Matrix platforms enable patient-specific orthopedic and facial implants, already validated in more than 250 clinical cases. By using 3D printed magnesium scaffolds that safely dissolve as bone regenerates, OIO Labs reduces surgical time, improves recovery, and minimizes the need for follow-up operations. It's precision medicine, engineered through additive manufacturing, designed for healing, and powered by AI. Perfy Technologies is pioneering volumetric additive manufacturing, a game-changing process that prints complete 3D parts in seconds, not hours. By projecting light patterns into a rotating vat of resin, their system forms entire objects in one go, eliminating layers, supports, and waste. The compact desktop unit enables on-demand, point-of-care production for customized medical and dental devices, with a closed-loop resin recovery system for sustainability. Fast, precise, and solvent-free, Perfy is redefining what's possible in high-speed, sustainable 3D printing.
The whole world is talking about the need to rebuild supply chains. But many of my human colleagues overlook the fact that conventional manufacturing technology won't cut it. Distributed manufacturing needs a digital manufacturing method, like 3D printing. So me and my colleagues are an important part of the AM community.
So welcome back, ladies and gentlemen, here on the industry stage at Formnext 2025. Most important event, at least from my perspective, at the first day at Formnext is the Pitch Next event. Welcome to round number 2. And we will start, of course, with a great start of our second round of pitches here on stage. So great ideas in AM often start with bold designs. But turning those designs then later into high-performance parts can be a really, really long journey. And our next team is rethinking how fast and how far this journey can go. Please welcome, with a warm round of applause, Aaron Cho, CEO of Vixive. And remember, Vixive is also part of our Startup Award selection. Your vote later can support them. Please, Aaron, stage is yours.
Hi everyone, my name is Aaron Chow, the founder and CEO of Vixive, and what we do is we address one of the fundamental problems that affects every single one of us, which is how do you make sure you have the right design for your process, for your material, and for your performance that you're trying to accomplish. And that's all we do, and that's how we build it. So the big question for always with design is getting to an initial design is very, very quick and typically very easy. Now, refining that design so that it's cheap enough to produce, so that it has enough performance for you to build it, and so that it can be done at scale is where a lot of the problem comes in. This process is very iterative, is always running loops of testing and checking, and this can take months, if not years. The way that we address this at Vixive is we actually have built our own fundamental machine learning models from all practical data that actually is able to predict these high complexity structures automatically based on performance. Where other users are generating a shape and then investigating what that shape does, we are able to take the best of generative design and pull from those industry performance and actually turn that into a set of usable shapes. So what does this look like from a demo side of things? We can actually show you a demo of the tool itself. This was a drone body that we were doing for a defense customer. The setup really is this easy. It takes about 30 seconds to set this up, and within 3 minutes, we were able to actually generate about a dozen designs. Out of those designs, every single one of them is printable and manufacturable. It's just a question of the balance of those parameters for the end user. Where our specialty comes in for our software is we're able to actually output a host of recommended designs. Some designs might be lighter, some might be stronger, some might manufacture better or have a different stiffness. Within a few minutes, we'll actually present a whole host of designs that as the designer, you are able to actually pick from. So this is not saying, hey, this one design is the best. It's saying use your knowledge in conjunction with our mathematics to be able to eliminate the design of experiments for mostly failed designs and only select from designs that you know will work. Since 2023, we've raised $5.5 million in venture capital over 2 series of funding. We actually just launched our tool in October of 2025, and you can see actually a live demo at our booth just over here in the startup area. Right now, we're just locked to single material and single machine. Again, all of these models were practically built, which means it takes time for us to build additional models. We're actively working for new machines, new materials, new processes, and accelerating these design life cycles from matter of months down to a matter of minutes.
Thank you so much. Big applause. Aaron. So I must admit that AI is one of my favorite topics. So let me ask you the following question. So where are there already real production use cases? So where one of your solutions is being produced afterwards with AI? Great.
Yeah, actually in the last month, we've seen a few major ones. One is defense use cases, like you see with the drone body, where we're making parts that are lighter, faster, actually faster to print and have higher performance. The other one where we're seeing a lot of traction is specifically within heavy industrial capacity. A lot of places where they might not have expert AM engineers like we have here, a lot of these organizations are finding that they can actually reach 85–90% of that performance in just a few minutes with their existing workforces.
And the next question is, of course, how does it change the traditional process? I got you with the iterative process, so you have to test it again, but then I get 20 designs from you, and I still have to test it, right?
Yep. So that's where the change now becomes, instead of guess and check for as long or as much money as you have, the equation now becomes predict and validate. So you are still checking the design, but usually that is doing what the essentially last check of your previous process would have been doing, cutting out everything in the middle.
Awesome. So to ask you further questions, you just have to go later on a few steps to the right to the startup area. It was a pleasure having you.
Thank you so much.
Big applause, ladies and gentlemen.
Thank you.
So if we're talking about high performance printing, it often comes with high complexity. And our next team takes a totally different approach, simplifying the process while pushing capability forward. And please welcome Sandra Ivares, co-founder of TVM OI, and don't forget to support them as well with your vote, because they are also in the Startup Award voting process. So please, welcome on stage.
Thank you. It's really great to be here, especially really great to see almost full audience. It says that this topic is very interesting for you. Let's start by asking a couple of questions. You all in the audience, how many of you have seen a cast metal part? Castings? Just raise your hand. Yeah? Quite many. How many of you have touched cast metal part? Almost same number of hands. And lastly, how many of you have directly or indirectly worked with cast metal parts, whether it's purchasing, manufacturing, quality organization? Couple. Okay, not too many. Usually there is more, but I'll forgive you that. Castings are one great example that there is still some fundamental issues in traditional manufacturing. Most importantly, there is huge lead times, anything between several months to even up to 2 years in worst case scenarios in special castings. On top of that, there is usually quite poor quality. Quality errors are quite significant. Inefficient material usage, the thermal it's uncontrolled thermal process in the end. So it's not the perfect manufacturing method. Luckily, we have a solution for that. Just by utilizing off-the-shelf welding robot arms, off-the-shelf welding power saws, and off-the-shelf welding wires, in addition to some specialized software and monitoring system and sensors, we can do 3D printing process directed energy deposition. It's metal 3D printing, made in usually very large scale. It fixes quite many of those issues which castings rises. You have more design freedom. You can easily get minus 80% in delivery times and lead times. It's a single type of raw material, so the security of supply chain is much better than in traditional manufacturing methods. Yep. Not only, it's not going to help you if you have the correct equipment. You also need to know how to produce high quality parts. And that's where we step in. With our team, we have a long withstanding experience in additive manufacturing, welding, machining, and handling complex supply chains. And we offer, especially in Finnish and Nordic markets, but of course here we are in the Central Europe, also the Central Europe, a comprehensive end-to-end service service for large-scale metal AM, especially in prototyping, spare parts, and customized products, where we can get reduced lead times, we can empower your circular economy activities, and decrease your time to market in end use case. My time is up. Our booth is there 20 meters that way in the startup area. We are happy to chat more about this. Thank you.
Awesome. Thank you so much, Sante. Big applause for you. So I always like to talk about applications. Probably you can share with us one or two things that already used your high performance approach.
Yeah. So there is not single specific industry that get advantages out of this. I think the most competent and usual ones that currently globally we have already are, for example, process industry, oil and gas, basically any lightweight critical applications, automotive, space, aviation, things like that. Maritime is one good example. So basically every industry where you are dealing with rather large-scale one-off components or large-scale serial production.
And how's the acceptance of the potential customers? Because you mentioned the industry, so we're mainly talking about critical parts. What is the perception you had so far?
Yeah, I have a little bit mixed signals on that. Luckily, past couple of years, the industry has been getting much more forward with the acceptance also. Of course, standards are usually lacking a little bit behind, but there is still good ways to certify the components, even the most demanding industries, let's say pressure equipment directive or aviation, so nuclear. So if we can utilize parts in those kind of industries, we can easily utilize them also in, let's say, basic level industries also.
Very good. So best of luck for you. And good luck for the awards ceremony if you're one of the winners. So big applause, ladies and gentlemen. TVM OI.
Thank you.
And Terry. So when personalization meets speed, entire industries can change, especially in healthcare. Our next presenter shows how smart digital workflows can make custom solution faster and more accessible than ever. Please welcome one of our Startup Award finalists, Anna Danielak from Perfy Technologies. Please.
Thank you, Stefan. My name is Anna. I am a co-founder and chief product officer of Perfy, and we work with a new ultra-fast additive manufacturing. Now, our goal at Perfy is to provide a technology that can produce the entire part within just 10 minutes. And that includes both printing and post-processing directly at the point of delivery. And we can do this with our new technology called tomographic volumetric printing, which uses the principle of photopolymerization. However, instead of layer by layer, it exposes the light from the side onto a rotating cylinder that hardens this material instantly. Now, with this technology, we can print full-size parts within seconds as opposed to hours, as it is with traditional additive manufacturing. Now, aside the speed, it brings another major benefit. In the traditional layer-by-layer production, we have a massive issue with very rough surfaces. And I think I speak for everyone here when I say what a pain it is to remove them. Just if you walk around Formnext, you can see how many companies have ramped up their post-processing activities. Now, because our principle is different, our parts come out of the machine smooth and shiny. There is no more support structures and no more manual polishing. We will be supplying this technology in the form of a standalone printing and post-processing unit with a fully integrated cloud-based calculation software, and we will be providing our customers with a capsules that you can just click and print with a raw photopolymer resin tailored for a variety of applications where there is a clear need for a local, fast, and easy manufacturing of personalized devices. And we start with audiology for a good reason. First of all, it is a niche market with a very strong need to decentralize and streamline production of custom-made ear molds for a variety of applications. Second, if we look at the global audiology key players, Demand, GN, and WS Audiologies are companies that are based in Denmark, where Perfy is from. And together they represent over 60% of the total global market share, meaning that Perfy has a direct access to the world's strongest audio ecosystem. And we have been in conversation with these companies, as well as private and public clinics, and they have all expressed very strong interest in our technology and had a chance to try our very first prototype themselves. Perfy was incorporated in 2024. We have just closed our pre-seed investment round this summer, with which we have managed to secure a patent agreement on the family of 3 patents. We have also just received a positive biocompatibility assessment of our parts. And we have also built a brand new, sleek and small prototype that is ready for further testing. And to do this, we have gathered a fantastic team of experts on both technical and business side. We are also very proud to be a truly international Danish, Polish, Chinese founding team. And we have also brought our prototype. So drop by to the startup area to see the live print demo in action. Thank you, and I look forward to your questions.
Awesome. Thank you so much, Anna. So as I know from the past that being a startup in the field of medical is one of the most stressful experience because you have to go through medical regulation. So how difficult it is, how far you are already. I mean, you mentioned a little bit, but elaborate on that.
Yes, the underlying approach that we are taking is to work only with material suppliers that already have experience within either ear molds or dental applications and biomedical, so we know we are safe on the side of their experience. We have conducted the biocompatibility test. We know that the process is stable, and right now we are looking into pushing the further documentation part with the EU for the full MDR approval.
Which is a lot of paper, I see.
It is a lot of paperwork.
Which applications do you expect to adopt single-visit workflows next? So what are the next applications you are heading for?
Interestingly enough, we have been asked about optical applications, I think 4 or 6 times today.
Okay.
Just before launch. So I believe that this is a big area. Within audiology, of course, we have hearing protection, defense, which we are already tapping into, and then the big behemoth of additive manufacturing, dental.
Okay, awesome. Thank you so much, Anna. Pleasure having you. Good luck for the award.
Thank you.
And see you in the startup area. Thank you so much.
Thank you very much.
Ladies and gentlemen. So we stay in the field of medical because in medical applications, precision isn't just a benefit. It can change lives. Our next team is pushing the boundaries of what is possible when surgery, digital planning, and AM come together. Please welcome Pacharamit Promopatum, quite a complicated name, but he will say it much better, CTO and co-founder of OIO Labs. Please, stage is yours.
Thank you. Hello, everyone. You can call me Joe. I am co-founder and CTO of OIO Labs. At OIO Labs, our vision is to tackle the most complex surgical problem using AI and 3D print technology. Let me give you an example. The picture you see here is patient with oral cancer. It's the most fifth common cancer found in the world. It kills around 400,000 people around the world every year. The treatment of cancer is so complex, mainly for 2 reasons. Even though the patient would need surgery, but the surgeon still plan the surgery based on the 2D film. But our body is in 3 dimensions. It means you need to translate the 2D planning into 3D surgery. That can already create a challenge. Second, today's devices, 90% of them still mass produced, but our body is unique. It means that the surgeon needs to do a lot of manipulation with the device and hope that it would fit to the patient. Combining all these challenges, even though treatment could be given, the outcome is suboptimal. It could lead to high blood loss, and it could lead to very expensive surgical bills. And these are the entire problem that we like to tackle. And the way we tackle it is, we start by developing the AI-led surgical planning platform. It converted entirely 2D planning into 3 dimensions. Once we get the input from the surgeons, our platform can create the patient-specific custom devices. Once these devices confirmed by the surgeon, the file gets sent to our 3D printing facility. It gets printed and shipped to the surgeon right before the surgery. The entire process only takes around 3 to 5 days until the surgeons get the device. Outcome is clear. The picture here is the surgical outcome of the patient. You see computer planning on the left, and you see how perfectly matched between the planning and the outcome. And if you look into the patient face, this is what happened to him 3 months after the surgery. Looking at the facial symmetry, I bet that you could not even tell. This is the same person who has a life-threatening tumor and been through 10-hour-long surgery. Not only we improve surgical result, but other impact is very clear. We cut back surgical time by about 50%. The surgeries used to be about 24 hours. We cut back to them to about 10. And the entire cost time reduction leads to about 25% in the surgical cost reduction. Not only we work on titanium, but our company pushing to develop the world first bio 3D printed bioresorbable magnesium implant. Unlike titanium that stay forever in the body, we vision the future that in the future, once the bone healing is completed, the metal can also be gone completely from the body. Right now, we conduct preclinical tests already, and we hope to have in-human pilot early next year. Using our technology, we already have produced more than 50 different medical devices. We filed more than 30 patents in 4 countries, Thailand, Singapore, EU, and US. Even though our market now is mainly in Southeast Asia, but we hope for EU and US expansion by the end of next year. Right now, we have conducted more than 300 clinical cases using our device, our technology. We have seen 0 complication, 100% surgeon satisfaction. Our technology is backed by world-class partner. We are part of innovation program from Johnson & Johnson, also a part of MedTech Innovator, which is the largest medical accelerator in the world. Medical device industry is challenging and exciting, and I believe that we have a team that can deliver perfect execution. And we are actively looking for partners in EU to onboard for our journey. That's all about us. Thank you very much.
Awesome. Thank you so much. That was really awesome.
Thank you.
So first of all, let me ask you a private question. When do I can get my knee replaced with your technology?
I mean, right now, we work mainly on craniomaxillofacial and hopefully slowly penetrating into hip and knee. Probably like towards sometime next year.
Okay, so
yes.
I'm very relieved on that. How does the implant change the recovery outcome? Because you mentioned the financial status at the end, but how does it change? I mean, we have seen the person. So what is on the medical side, the outcome?
I think the benefit about patient specific is you cut back the time that you perform the surgeries. And typically when the surgery gets shorter, you kind of being less blood loss and you being less number of hours that you have been sleeping during the surgery. Everything combined is actually get you discharged to the hospital much more quickly. Giving the numbers, typically if you need to stay in hospital for 5 days, once you use the patient-specific medical device, those 5 days will reduce to about 2 to 3 days.
Awesome. So the healing is much better as well.
Definitely, and also the precision.
That is excellent. So big applause for you again. I'm super happy that you have been here and founder. Good luck for the future, because this is something we get the profit, all of us, out of it. Thank you so much. Big applause, Joe, ladies and gentlemen.
Thank you.
So, ladies and gentlemen, some of the most exciting breakthroughs in AM come from looking at nature itself. How it moves, how it adapts, how it builds structure. Our next presenter follows exactly this idea, bringing biological inspiration into advanced manufacturing. Please welcome Gregor Weisgrab, CEO and founder of Biomotion Technologies FlexCo. Welcome on stage. Big applause, ladies and gentlemen.
Thank you so much. My name is Gregor Weisgrab, CEO and founder of Biomotion Technologies. And we standardize the production of human tissues to accelerate how pharma finds new drugs. Now, bit of a detour. Every single time pharma develops a new drug, it's a $2.5 billion gamble. Now add to this, the moment a drug gets tested in a human for the first time, 90% actually fail. And that's even though pharma just vigorously screen them, spend hundreds of millions in the preclinical phase. So that's a lot of wasted resources. And now you have to understand why is that? Well, animal models and 2D cell cultures just don't properly recapitulate how human biology is organized. But there's a solution, and these are 3D tissue models. They could do that, but at the moment they're very hard to reproduce and very slow to scale, which leaves pharma with a very slow workflow. And we deliver what this industry really needs. We deliver automated and standardized 3D tissue manufacturing at scale. With our system, with our biofabrication system, where we have 90% reproducibility, we cut labor by 70% and we increase throughput by 4 times. We do this with our end-to-end workflow that's fully implemented on our bioprinter system. We give a new material to a bioprinter. This device learns how this combination of biomaterial and human stem cell gets printed, and then applies this knowledge to the subsequent bioprinting process. So as a user, at the end, you get the same tissue model every single time, plus you get the data for your quality management system to prove that it's actually the same system. We provide our users with the whole production system for 3D tissue models that comes with the bioprinting device itself, with the built-in process control, as well as with a range of biomaterials and a software that has built-in geometries that really takes you from, that take pharma from a 2D tissue model to a 3D tissue model in a breeze. With this solution, we initially tackle biotech companies and contract research organizations, and we can deliver printed to them and get up to 10x return per device per manufacturer. But the billion-dollar opportunity for us is by tackling pharma directly in the form of tissue models, in the form of cartridges that they can print on-site, on demand, whenever they want to do so. Our team is currently led by Stefan and myself, and we combine deep knowledge in biofabrication and mechatronics, and we are followed by a strong team of engineers and industry advisors that really help us through in the development phase. In this last couple months, we were able to secure first paid pre-order device, as well as secure just under 2 million in public funding to secure our tech roadmap. And we're currently expanding the types of use cases in the form of partnerships with pharmaceutical applications. That being said, next year we are opening our first pre-seed seed round of 1.5 million. We already have 0.4 committed. We're looking for further investors to join us in this goal to bring biologics to the market that will define how we manufacture tomorrow's medicine. With Biomotion Technologies, thank you very much.
Awesome, Gregor. Fantastic presentation, by the way. Thank you so much. Yeah, let me ask you one question. Where do you see the biggest demand for standardized 3D printed tissues?
Right. So we see huge demand from pharmaceutical industries. There's now been a switch from the FDA on what's being accepted in preclinical stages. We are no longer, some areas are no longer required to really test on animals, but they can also use alternative methods. So here we see a huge pull. And what's also very interesting is we also see a first pull for 3D printed living implants. So that's actually, we're currently working on a cartilage implant as well through the product that I showed earlier. And this is also really interesting in how you need process standardization, because you have the blueprint for, let's say, a cartilage product, but then you mass standardize it for every patient, which again introduces different ways on how to print it. And that's perfectly suitable for 3D printing or bioprinting.
Awesome. And are you cooperating with some of the pharma companies? Is there already a cooperation in place, or do they, because some of them are doing it themselves, right? I mean, as far as I know.
Yes, absolutely. So there are some early stages in place. There's also cooperations with biotech companies that then sell this solution to pharma. And these are the ones who reach out to us initially and they say, hey, we have this very cool product. There's a need for this, but we need to have it standardized. We can't deliver it the way we deliver it right now. And so these are our initial customers.
Great startup, great initiative. Thank you so much.
Perfect.
Big applause, ladies and gentlemen.
Thank you so much. Thank you.
So, ladies and gentlemen, as products become more personalized, the real challenge is designing them fast, consistently, and at scale. Our next startup focuses exactly on this, creating automated design tools that generate custom solutions with speed and precision. And therefore, please welcome on stage Manuel Biedermann, co-founder and CEO of Nurio AG, and I'm super excited what they have to tell us. Please, Manuel.
Hello, everyone. Before I start my presentation, I have two questions for you. By a show of hands, who of you thinks that additive manufacturing offers really a great potential and is very fascinating? Awesome. Now, my second question, who of you would be able to design such a part within one day? Please show our hands. Okay, few hands, but not too many, right? And this is exactly one of the key bottlenecks that we have today with additive manufacturing. To really drive applications, we need designs. But today, the design is oftentimes still manual, very time-consuming. Oftentimes it takes weeks to months to create a design. You need to consider the restrictions for additive manufacturing. You need to know the CAD skills. So it's really a great barrier, especially for beginners. With our startup, we are solving exactly this problem. We are developing new design tools to simplify and automate the design of parts and products. With our tools, we automate especially those manual, repetitive design tasks. They take a lot of time. We enable non-experts to design parts and products for additive manufacturing and generate production-ready designs, even if you are not a CAD expert. We do this for a variety of applications. Here you see one example for fluid manifolds, where you just specify the inlets, outlets, your manufacturing restrictions, and then with our design tools, you can easily generate one design variant or many different ones to easily compare costs, performance, and other criteria. We develop such design tools for a number of applications, ranging from fluid flow applications, factory tools, production ads, consumer products, or personalized parts and products. With our design tools, we automate the design process either through existing tools where we provide add-ons for software solutions such as Siemens, CATIA, SolidWorks, but we also make our design tools available through web-based access or standalone software. With this, we really cover different users and use cases. Our founding team comes from ETH Zurich with many years of experience in design automation and additive manufacturing. Besides myself, Manuel, we have Patrick, our CTO, and Urs, our COO. Over the last years, we've been working with many different companies. Here I want to highlight Siemens, HP, Stäubli, and many other customers. Here at Formnext, I really invite you to join us at our booth, which is directly here, to discuss your design ideas and also experience our design tools. Also, we have a number of demo tools that you can try out. And with this, I want to close my presentation and really to have you inspired for new design tools. Thank you very much.
Big applause, Manuel. Thank you so much for the presentation. So sometimes when I hear those solutions, I'm a little bit scared because sometimes I think, is it then really a job of the future being designer anymore if it's all automated? That's a really big question. But you mentioned some areas, but what product benefits most out of your solution? What kind of category? What would you say?
So I think it's really about automating all these repetitive tasks where a designer spends a lot of non-value adding time, where design tools can really provide a big benefit. And it's not about automating the designer away, it's really about making designers more productive and enabling more people to create parts for additive manufacturing.
Probably as a first step, but then in a second step would be interesting for me. So once a design is automated generated, how do you ensure, how do you say that it's production ready afterwards? I mean, what is the quality or regulation perspective in it?
Yeah, so that's a key point. As a user, you not only specify functional inputs, but also restrictions for additive manufacturing, such as the build direction, minimal build angle, wall thickness criteria, to really ensure that what you generate is also production ready and fulfills all restrictions.
Yeah. So we know that, for example, I need to ask another question because I met the guy from Autodesk with Fusion. They have that already in place with an AI-generated model. So is it like competing or is it like an add-on? Can you already use it in Fusion as well? Or what are the typical customers that are using it?
So we really see our design tools as extensions and add-ons for the existing CAD software. Usually users, they kind of lack the specific features that they need for their application. And this is the gap where we come in, where we provide custom extensions and add-ons for tools like Fusion maybe, but also NX, CATIA, and others.
Awesome. Thank you so much. Big applause for you, Manuel. Great presentation. Thank you, ladies and gentlemen. So, last pitch in this round will be something about innovation. Some innovations don't just improve a product. They rethink how an entire category of machines can be built. Our next startup explores a radically different approach that could reshape the future of robotics. And I saw the slides and I'm super excited to hear them. Please welcome with me David Holo, Chief Product Officer of Alonic. Please, David, stage is yours.
Thank you very much. My name is David Hollow. I am the co-founder and chief product officer of Alonic. I'm excited to share with you the technology that we are bringing to the market. Robotics are costly, complex, and just generally difficult. To design and develop robotic products, you need large teams of specialists with difficult to come by skill sets. And if your robot needs to work with or around people, complexity increases because safety becomes a major concern, just compounding the costs. And like all products, robots especially need many iterations to get right. Recent advancements in AI and machine learning has made software-based control fairly easy, if not feasible, but hardware is lagging behind. And this is what we set out to address with our technology that we call tissue braiding. It makes the design of robots simple, production practical, and the resulting mechanisms are inherently safe due to the compliant nature of the materials. 3D tissue braiding is a new, simpler way to build robotics. You start out with the scaffolding. You can think of it as like a skeleton made of bones. And you basically push it through the machine, where technical fibers get deposited and intertwined over the scaffolding, forming functional tissues. The resulting products just need to be connected to actuators, and you have a working robotic product. This design-to-production technology eliminates the need for the multitudes of metal parts, precision parts, that make up the linkage-based mechanisms that are prevalent in robotics today. This radically reduces the number of parts that go into a robotic product. It also decreases production time and cost. You can go from an idea to a pilot in a matter of hours with a couple of engineers instead of entire departments of them, making design simple, fast, and cheap. And the best part is you can do this all in-house with a single platform instead of having to wrangle entire networks of suppliers. So whether you're looking to automate your factory with dexterous manipulators for ever-changing tasks, or you're a startup with a novel idea for a robotic platform that you're bringing to an emerging market, or you're a major company looking to bring robotic products to consumers, we are currently designing our second-generation tissue braider that is able to produce arm and leg-sized parts in under an hour, making it ideal for volume production. In the name of our entire team, I'd like to thank you for your attention. Please feel free to drop by our stand, and I'm looking forward to answering any questions that you may have. Thank you.
First of all, big applause. Still amazing. So let me ask you, and I have no clue, so let me ask you, I probably still do not understand it. So you built real robots out of this technology? Because
Yes.
when I first thought, I was like, wow, how's that working? So is there a basic robot and you just do the housing? It's not the housing, it's really
not the
functionality,
housing.
right?
It is a functionality, yeah. So we started with hands and we built entire fingers in a single process. So instead of having 30 parts comprising a finger, we have literally 5 parts. That's it.
That is awesome. So what are the first use cases? Are you already in some use cases in the industry where we can find your kind of robotics?
Yes. So we actually started out, and the way we arrived at this technology is we were designing prosthetic hands. We were trying to solve the embodiment problem in robotics. So hands are obviously existing product lines that we are actively developing. Also dexterous manipulators of all sorts. So 3-finger grippers and like, but we have a couple of interesting collaborations lined up that I can't discuss yet.
So, and do you vary the surface? Because let's take a hand that is touching something, should it be more grabby or more easily slide over. So it's something you can provide, or is it always the same material?
So we can actually use different fibers depending on what sort of functionality is required. So we can use low friction materials for moving components, or we can use high friction materials for covers and grippy surfaces.
That is awesome. Thank you so much.
Thank
Great
you.
presentation. Ladies and gentlemen, big applause. Yeah, second round of pitches is over. And before we come to the next round and final round, please feel free to enjoy some Formnext highlights here on stage or on the screen. And we will be back at 5 minutes past 3:30. So very complicated. 3:35. See you then. Bye-bye.
From craftsmanship to code, Fidentus GmbH is transforming dental technology. A Fraunhofer IGCV spin-off, Fidentus has developed the world's first commercial multi-material additive manufacturing process for telescopic prosthetics. This innovation allows the fusion of precious and non-precious metal alloys like cobalt, chromium, molybdenum, and gold within a single build, achieving micrometer precision and eliminating manual adjustments. Where traditional dentures required years of expertise and labor-intensive polishing, Fidentus delivers patient-specific prosthetic frameworks with engineered friction fit built directly into the design. The result is reduced metal waste, greater consistency, and scalable digital production. By bridging CAD/CAM workflows with industrialized multi-material AM, Fidentus establishes the first fully digital chain for removable dentures, redefining precision, access, and quality in dental care. Sometimes innovation begins with the smallest breath. 3D My Mask, developed by Digifab in collaboration with the International Advanced Manufacturing 3D Hub, creates custom silicone masks for premature infants using 3D scanning and additive manufacturing. In neonatal care, one size has never fit all. Standard nasal interfaces often cause air leaks, pressure injuries, and craniofacial strain. 3D My Mask changes that by tailoring every curve to each child's unique anatomy, reducing air leakage by up to 60% and improving comfort and safety for the most fragile patients. Driven by a clinical industrial alliance that includes Hospital Clínic de Barcelona, IAM 3D Hub, and multiple technology partners, 3D My Mask shows how empathy and engineering can breathe new life into medical innovation, because even the tiniest patients deserve the best of technology from their very first breath. At Tesseract Technologies, motion itself is being re-engineered. Traditional large-format 3D printers depend on belt-driven stepper motors. Tesseract replaces belts with proprietary linear motors that glide directly over magnetic rails, eliminating transmission errors, improving speed, and ensuring consistent print quality regardless of printer size. The secret is accessibility. By designing their own motors from the ground up, Tesseract has cut costs by 5 to 10 times compared to industrial alternatives, without compromising performance. Already piloted with leading manufacturers, this technology brings industrial-grade motion control into reach for the entire 3D printing sector. With Tesseract, large-format printing is no longer a compromise. It's a new benchmark for precision, reliability, and speed.
Riding a motorbike you restored yourself is a unique and defining experience. Every single part of the system is important, no matter how small it is. I support the AM community with this same passion by finding and creating the best materials for functioning production concepts.
Hello, ladies and gentlemen, and welcome back here to our final pitching round at our Pitch Next event on Formnext 2025 here at the industry stage. We now come to the final pitching block, the Rookie Award finals, and they are really exciting. I tell you why. Because this award celebrates bright new ideas from founders who have not yet launched a company or who are less than a year into it. These teams work at the very earliest stage, where imagination is still bigger than budgets. And where every idea starts with, what if we could make this or that easier, faster, or better? Let's see what the next generation of AM innovators is dreaming up. And let's come directly to our first pitching here. So dental care may not be the first thing you think about when we talk about revolutionary AM innovations, but it's an area where precision, comfort, and speed truly matters, and everybody can confirm who has been to the dentist recently. So our next presenter is bringing a fresh perspective to this field by rethinking how modern dentures can be designed and manufactured. Please give a warm round of applause to Max Horn from Fidentus. Max, stage is yours.
Thank you very much for this very warm welcome, nice introduction. Hello, my name is Max, CEO and co-founder of Fidentus. And imagine you had the freedom to combine any metal or metal alloys into complex components in a single, simple 3D printing process. Imagine the complexity and performance density that you could create using this technology. Well, you can stop imagining, obviously, because we developed a multi-material 3D printing system that enables you to do exactly that. Our technology core consists of 3 components. First, a hardware extension for commercial 3D printers, the software solution to handle the multi-material data, and obviously end-to-end process know-how to enable these parts. But our technology is actually not the product. Instead, we use it to enable the most demanding applications and create value for our customers, you, for example. We successfully did this already in the dental industry. The image you can see here is a special type of dental prosthesis, a denture. And at its core, it consists of 2 materials, a cobalt chromium and a gold alloy. Now, we didn't invent the product. It's been there for ages, but it's very hard and fickle to produce. Dental technicians have done this over the last decades in a manual process. So you have the manual bottleneck and the decreasing talent. At the same time, a rising, aging population. So the supply can't solve the demand. And obviously with all the manual processes, you have inconsistent quality. Now, our solution helps dental technicians to solve their bottleneck, the production. So they basically design the dentures, send us the data, our production system produces it, and they do the veneering, the final touch. With this system, we actually can make, as it's a digital process, we can make the dental craftsmanship scalable and reproducible, so we eliminate the guesswork. With this application, or with our technology, we enter our beachhead market of dental prosthesis. It's a €1 billion market with significant growth, and this application we're targeting has at least 330,000 dentures produced in Germany each year. Now, this might sound far-fetched, but we have actually qualified the entire process chain, from data generation over production to then heat treatment, surface milling, and powder recycling for this multi-material process where you handle different materials simultaneously. And this enabled us to actually produce parts that are in operation in patients. What you see here is the first operational multi-material laser powder bed fusion component ever produced, and there are more patients actually wearing our dentures. We achieved this in just 1 year since we started. We are currently closing a funding round to scale our vision in the dental industry and also explore other verticals. I'm not doing this alone, but I have this fantastic team of co-founders and people we're working together with, and you can join us. Multimaterial AM is here, and we're at the forefront of it. Thank you very much.
Big applause, ladies and gentlemen. You know what is so frustrating? Yeah, if you're 50 and you think, what if I had been born like 20 years later? Then I would profit from all of this that you are presenting. Sorry for that. I needed to say that. So how close are you in integrating it in dental procedures already? I mean, how close are you to, let's say, being a standard?
So almost there. So when we close the funding round, we can set up our serial production. At the moment, the capacity we have in the institute, we're spinning off. So we're founded just earlier this year in January. That's basically the bottleneck. So when we have our own production, we can be in the dental practices sometime mid to end of next year.
Awesome. So it's still a very regulated area. So how easy is it to get into that industry? I mean, what are the first responses, probably concerns that your potential clients have?
Actually, the one thing I love about dental technicians, they're very hands-on. They're craftsmen, right?
Yeah.
And they have found very innovative solutions to cope with the regulatory affairs themselves. So they're very open to it. And they basically said, nice solution, let's get it done. And that's exactly the spirit that we needed. And with this, we could address all the other regulatory affairs. So it's basically about being agile and getting things done.
Awesome. Thank you so much. Big applause for you, ladies and gentlemen. We have to wait another 2 or 3 years. Then we are covered by this solution. Thank you so much. 1 year. Yeah, even better, even better. So, ladies and gentlemen, we are coming to a project in cooperation of IM, 3D Hub and Digifab. And some innovations remind us why personalization truly matters, especially in healthcare. Our next team is working on a solution designed to improve comfort, safety, and treatment quality for some of the most vulnerable patients. Our next rookie finalist explores this idea. Please welcome with me David Adrovea presenting the project 3D My Mask. Please, David, stage is yours.
Hello, good afternoon. So this is David Adrover from the International Advanced Manufacturing 3D Hub, and I want to introduce you the 3D My Mask project because every year millions of premature babies require non-invasive ventilation systems in neonatal intensive care units in hospitals. In the Hospital Clinic of Barcelona, all alone, over 75% of those premature babies require this kind of non-invasive ventilation systems for an average of 10 days. The problem, the nasal interfaces that only comes in 4 fixed sizes, none of those fitting precisely the baby's facial anatomies. This is causing a lot of side effects like skin ulcers and even cranial deformations. And that's caused mainly due to overly tight fixation systems in the baby's heads to prevent air leakages around the baby's nose. So seeing that, we wanted to address this and provide a customized solution to these youngest and most fragile patients we serve to enhance their stays on the hospitals. So we created this customized part, a small innovation enabled thanks to additive manufacturing technologies. So that's how we cooperated with Shining 3D in that case to run the facial 3D scans of the babies on hospitals and then create the customized parts to be delivered on field thanks to use Linkster and Elkem's 3D printing with silicons. This is a small innovation where we found a decrease of 70% in air leakages around the nose, thanks to this more homogeneous pressure distribution around the baby's head and also decrease on 90% of these kind of side effects that are enhancing this stage on hospitals for these most fragile patients we serve. So we hope to continue developing this application to benchmark new technologies and new solutions that could be scaled around as much as hospitals as possible, and bring this idea into final life for these patients. Thank you very much.
Biggest applause ever possible for this solution. In fact, when I saw your presentation, I was personally affected because I'm a father of 2 early born, so we know exactly what you were talking about. But I know at the same time that how difficult is especially, I mean, I only know German healthcare system, so how difficult it is to implement these kind of procedures into the clinics, because even then, if it's about the most vulnerable patients, it's about money. Don't get me wrong. So what kind of challenges are you facing when introducing this solution to clinics or healthcare
As always in medical applications, it's regulatory and certification. When it comes to new applications, new materials, and that 3D printing in silicons, it's not so adopted yet in hospitals. So that's the first thing to overcome. And we expect also to have different solutions that we could deliver final parts already certified for final use into hospitals. So that's why we are considering technologies that might be already on 3D labs in hospitals, or with a broader adoption than other ones, while we continue developing these kind of solutions that might be better for this kind of application.
But how do I have to imagine this process-wise? Because I mean, the standard mesh you take out of the box, you put it on, and then it doesn't fit the baby. It doesn't matter at all. We are the closest. How long does it take to create such a mask for the baby?
That's another thing that we are working to optimize the full workflow, and in that case, minimize the time to part, or the production time. And thanks to working with the partners, we are considering the technologies that could be easily installed in hospitals, like handy 3D scans that could be used not only for this application, but for other ones, and even technologies that any kind of hospital could have directly in there, and it could be produced in a matter of hours if we also achieve to optimize the full design process. So that's our technical development roadmap.
Thank you. Thank you so much, David.
You're welcome.
It was a pleasure having you. Big applause, ladies and gentlemen. David, Adobe. So last pitch for today, but definitely not the last highlight, that's something I can promise already, is the following company. In large format 3D printing, speed and precision are often limited by the mechanics behind the machine. And everybody who uses a printer at home might know this already. Our next presenter takes a fresh look at this challenge and offers a bold alternative to traditional motion systems. Please welcome our final rookie finalist here on stage, who is Timothy Kramer from Tesseract Technologies. Please, Timothy, stage is yours.
All right, good afternoon, everyone. My name is Timothy Kramer, founder of Tesseract Technologies, where we make high-tech products affordable and accessible. Today, I'm here to discuss a big elephant in the room, which is the belt-driven system, as belt drives limit speed, precision, and reliability, especially when it comes down to large format printing. To better understand why this is, let's dive right in. First, stepper motors. Stepper motors are very efficient motors at low speeds, but it also makes them effective generators at high speeds, sending current back into the printer's power supply. And if the power supply can't handle this, it will clip, and we see degraded performance happening at higher speeds. BLDC or servo motors, on the other hand, have a far more favorable performance over a wider speed range, which makes you wonder, why don't we use these motors instead? Well, that brings us to the second issue, which are the belts. Belts are elastic in nature, just like a rubber band, and if you print fast, or with force, we can introduce vibrations. And for smaller machines, this is somewhat manageable through an input shaper. But for larger machines, the belt stiffness may have degraded significantly, giving the input shaper a much harder job in correcting these vibrations. Furthermore, belt stiffness changes with age and also with temperature, thus these belts require constant recalibration, which in the end is not great for the end user. So preferably, we want a drive system that is highly performing, scalable, but also easy to work with. Well, that brings us to our solution, which is our self-developed linear motor system, which is where our linear motors are essentially a linear version of a servo motor, thus providing high performance over a wide speed range, while being close to zero maintenance as we have eliminated the belt system altogether. So our solution consists of 3 core components. We have the linear motor, consisting of a rod of magnets and a rotor. Then we have a high precision encoder, and finally a closed loop controller or driver board, which corrects any deviation of the printhead while ensuring proper tracking using step and direction signals or canvas. Accessibility is key to us. That's why we have developed a web interface for which you can monitor any parameter related to the motor or make changes to the motor control system or motor configuration. We entered the market using 3 variants, ranging from 20 newtons up to 70 newtons of force, which is enough to serve most of the 3D printing needs. And we truly believe that with our motors, we can really help additive manufacturing advance forward. We can introduce new innovations. Imagine multi-gantry printing, as you can see on the slide, which is done way simpler using linear motor technology. Or we can achieve very high speeds and accelerations using a quad gantry design, where we place the motors along the frame. So we have some interesting demos set up at our booth at the startup area, so please come by and have a look. And let's discuss together how we can advance additive manufacturing forward. Appreciate your time, and thank you very much.
Awesome. First of all, I love excellent timekeeping. That was excellent timekeeping, leaving enough room for questions. I always like to talk about industries applying the technology because, it's not groundbreaking at the first view, but definitely on the second view. And a few of the machine producers will kind of have issues of implementing it. So which industry you see the first step?
Well, we see the first industry here, right here at Formnext, at the additive manufacturing industry, I'd say. That's where we really see high speeds and high accelerations being made possible with smaller machines, but we simply cannot expand that to the large format printers. So we have one pilot partner. They're actually also here present on Formnext, which is Felix Printers, using our motors in their printer, and they have a 1 meter by 1.5 meter in size printer. So yeah, we definitely see a lot of potential here in this industry to make a true impact.
Let's compare, beside the increased speed, for example, that you mentioned, let's compare costs for a moment. Is that something you have taken into consideration? Or?
Absolutely. So we have done everything what we can to drive down the cost, and it's an ongoing process. So there are 3 ways how we have reduced the cost significantly. We have optimized these motors, first of all, specifically for 3D printing. Secondly, we have done some really smart design choices to keep assembly as simple as possible to further drive down the cost. And finally, off-the-shelf components, especially when it comes down to the controller board, to really keep the cost down as much as we can. And all in all, that resulted in a cost reduction of 5 to 10 times if we compare that to linear motor companies.
That's awesome. And furthermore, so let's take a look at the product quality as well. So how does the product quality change? Or what you say, we just guarantee it stays the same, or it's getting even better?
Well, it's definitely getting better. So we are, and this is actually quite a funny thing. A lot of 3D printer companies don't tell you what their accuracy is. And we do. We are, if you tune your control system well and your system is mechanically sound, you are within 50 microns of accuracy. But we do have a high precision encoder that can go down to half a micron resolution. So depending on how fast you move, the closer you get to that 0.
Awesome. Thank you very much.
Appreciate it.
Big applause for it, Tesseract.
Thank you very much.
We have seen you in the video as well. Good luck for the award. Thank you so much.
Have a nice day.
Ladies and gentlemen, this was one of my favorite events here at Formnext, and unfortunately it's already over, but you have still some tasks to do. So first of all, don't forget Formnext Awards Thursday afternoon here on the stage. You should be present because a few of the pictures you have seen today, they are in a closer look and they have the possibility to win one of those awards, which will be very important for them. That leaves me with a task for you, because please, you still have the chance to vote for our award nominees, and you can have a look over there in the award area where you can see all the applications we have for the award finalists, and make your decision on for whom to vote. So don't be afraid, the program is not yet over, because you can first enjoy a few minutes of Formnext highlights, which is always very enjoyable. And after that, we step into a topic that might be one of the hottest right now in our industry. We are talking about mergers and acquisitions, and probably we have some news to share with you, so please stay tuned. We will see us in about 4.5 minutes here back on stage with 4 excellent panelists, and I'm looking forward to it. Thank you. See you soon.
At Continuum Powders, sustainability isn't an afterthought, it's the mission. The company is revolutionizing metal powder production by recycling certified aerospace waste into high-quality, application-ready alloys. Using its proprietary Greyhound melt-to-powder M2P platform, Continuum transforms scrap materials like nickel, titanium, and cobalt into premium powders that match and often exceed the performance of virgin materials. A life cycle study by Oregon State University revealed a staggering 99.7% reduction in greenhouse gas emissions, making this one of the cleanest powder production processes in the world. With its OptiVantage quality framework, Continuum ensures each batch meets aerospace-grade standards, proving that circularity and precision can coexist. From binder jetting to laser powder bed fusion, their powders are already powering the next generation of sustainable manufacturing, where waste becomes value and performance drives responsibility. EOS has reimagined the environmental footprint of metal additive manufacturing, starting with what's usually overlooked: waste. During every print, reactive byproducts like condensate and soot are formed, microscopic, hazardous, and costly to dispose of. EO's new next-generation filtration system turns this challenge into an opportunity. It neutralizes reactive particles within the process, transforming them into stable, recyclable metal oxides, all without chemicals or external passivation agents. At the same time, reusable powder is recovered, reducing material loss and cutting emissions by more than 90%. The result? Cleaner production, safer disposal, and a closed-loop filtration cycle that's both economically and environmentally sustainable. EOS is proving that innovation in additive manufacturing doesn't just mean building smarter machines, it means designing for a smarter planet. From the heart of southern Spain, Smart Materials 3D is turning everyday organic waste into extraordinary 3D printing materials, redefining what sustainability looks like in additive manufacturing. Their journey began with olive, the world's first 3D printing filament made from olive pits, a byproduct of Spain's thriving olive oil industry. What started as a regional experiment has evolved into a global sustainability model. Through their SmartFill Eco line, Smart Materials 3D transforms locally sourced organic waste, from oyster shells and pine wood to cork, coffee, and algae, into high-performance biodegradable filaments and pellets. These bio-based materials not only reduce virgin plastic use and carbon footprint, but also preserve natural aesthetics, producing filaments that look, feel, and perform beautifully across both desktop and large format 3D printers. Certified under ISO 9001, ISO 14001, REACH, and PEFC, Smart Materials 3D stands as proof that sustainable innovation can be both scientifically sound and artistically inspiring. Smart Materials 3D proudly showcases that innovation made in Spain isn't just advanced, it's responsible, renewable, and ready for the world.
throughout the week, we have loads of events. There's special cases, for example, for the construction industry. There's a special case by the VDMA for mechanical engineering. And there's loads of other events taking place. For example, our award ceremony on the Thursday night, where also our visitors can still vote to define the winner of the event. And then, of course, we have our stages with loads of presentations, of talks. There will be panels on very urgent topics. For example, there will, of course, be a review of the last 10 years, but there will also be an outlook for the next 10 years. We are talking about the role of desktop 3D printers in the context of adoption of additive manufacturing in the industry. And we're talking about mergers and acquisitions. So topics that really define and change the industry as we know it.
Hello, ladies and gentlemen, and welcome back here at the industry stage at Formnext 2025. And welcome back to a very interesting panel, I must say. So additive manufacturing, and we talked about this all morning already, has reached a new stage of maturity. And with maturity comes consolidation. So in recent years, we've seen major acquisition, strategic exits, and entire reshaping of the industrial landscape. Companies are buying not only technology, but access to materials, software, and applications. At the same time, others are exiting the market, unfortunately, or merging to survive. So what does this new M&A dynamic tell us about the future of additive manufacturing? Are we witnessing healthy consolidation or painful restructuring? And how will these deals define who leads the industrialization of AM in the coming decade? And this is exactly what we want to explore in this panel, M&A dynamics and the future of additive manufacturing. And as you can imagine, I'm not at all an expert in this topic, so I invited 4 experts, and with me on the panel, I'm super excited to have you all here, is to my left, Arno Gustavfeld, Managing Partner of AM Ventures. Big applause for Arno, ladies and gentlemen. Then we have Dr. Roman Bavinski, Lecturer in Strategy and International Business of the University of Bristol. Roman, great to have you here. Big applause for you. Very much. Then we have Hans-Alfred Bräuninger, who's consultant and managing partner at Bräuninger. Hans, big applause for you. Thanks for having you. And last but not least, Sophie, great to have you here. Sophie Berninger, CEO, Bosch Advanced Ceramics, subsidiary of Bosch Business Innovations, if I put that correctly. Okay?
Absolutely.
Thank you so much, Sophie. Big applause for you as well. So Arno, I need to cite you at the very beginning because you mentioned something, and I want to put that into my question. So how has the M&A environment in additive manufacturing changed from the hype years to today's, as you call it, post-reset phase?
Oh, that's how I called it.
Yeah, that's how I called it. I hope they put it correctly.
No, you're right. I think we are really post-reset. That whole resetting of expectations is hopefully behind us, and we are looking ahead with a much clearer picture. We went into this time 4 years ago, 5 years ago, with a lot of overhyped expectations. Many dreams were sold to people who built an expectation of what the future would look like. These promises were not necessarily completely fulfilled, sometimes not at all. So the past 2 to 3 years were extremely challenging for the entire industry, for many entrepreneurs, for a venture capitalist in additive manufacturing as well. But I am very confident that since about 3, 4, 5 months, we are seeing a complete change of vibe, of mood, of mindset in the industry, that customers are coming back, top line revenue is coming back, funding appetite is coming back strongly. So I think Formnext right now is happening at a great point in time because the outlook is much better than even half a year ago.
Which is good, and we will later on focus on that topic, how that converts into profit for the participants. Let's talk about that later. So Roman, so you do a lot of research on that topic, and if you look at the M&A deals, especially recent deals, why do you think some of them fail to achieve their intended value?
Oh, thanks. Great question. And if I was able to answer that, I would probably be a millionaire and not sitting here because I could consult every
Sorry
company.
for that.
But I can speak a bit of what we learned from doing M&A awards, where we looked at which companies really succeed in doing complex deals. And what we learned is that you need to have a very clear vision of the future, what your company should look like. And then you can search strategically for targets that help you transform your company into that future. And I think what we've seen in the M&A or in the A&M industry is that there was a lot of more opportunistic search, also driven by uncertainty. So firms became available, cash was there, so you buy something, but you don't really know how it will fit into your current business model or where you want to be in the future. And that creates a lot of complexity where you cannot integrate it well, and then you don't really generate value. So that would be a short, very subjective view of what I think.
Yeah, but interesting subject, and we will talk later about the amount of money that determines a little bit of how well planned the decisions have been made. Let's put it that way. Hans, coming to you. I mean, we have seen a lot of restructuring in a recent month, as Arno mentioned, in recent years. What have you seen, and what are the key drivers behind it? So I mentioned a few reasons to do so, but what do you see are the key drivers behind it?
We did an analysis of the pitch book figures, and since last year, there were more companies went bankrupt than they were involved in M&A transactions. So it's a kind of similar saying what Roman said. So the M&A transactions are going back, and the going out of business is increasing right now in the industry.
Yeah. So Sophie, I mean, you're actually representing one of the, let's call it startups, if I might say it so, that Arno just mentioned, and you give a promise as well. So considering the consolidating market, how do you approach scaling and getting faster, let's say, attractive for the market as a startup?
That's a very good question. Of course, even if we are internal corporate startups, we have also every year, even every half year, to really present us and to get the funding, internal funding. So if I summarize our strategic approach, I would say 3 pillars. First one is really laser sharp focus on growth in really over average growth in market segments. That's really matters. And for example, where we believe where the growth is the strongest. So second is, of course, we are talking about market, but the product fit to market. From my point of view, it's a very important strategic approach. So that's why we always focus on continuously optimizing, innovating our technology, and of course, to solve complex customer problems. That is where we get the money, right? Where we get the revenues. But for doing that, we also actively looking for partners who can also help us to put the boundaries of the technology to give customer more, I would say, more value to achieve that. So this is the second pillar. The third pillar is, I would say, the human people, the team, and they are really the driving force of the success. That's why we always, in the beginning, already focus on build a strong performance, a high performance, motivated, and especially I think in startups important with the entrepreneurial mindset. So for example, for my team, people are going extra mile. They just not do the task in which their area. They have a much broader task area, and so that they are also motivated for see the company BSC as their own company. So I would say these were the three important factors.
And let me ask another single question. So if I look at the, let's say the head of the incubator, so Bosch Innovations, so how fast they ask you for specific profit figures and how fast you get there? Has that changed over time? Is it more like looking into the technology and how it fit to the markets, or are they asking at a very early stage, when can we expect profit?
I have to pay attention if the founder is here. So, actually, we have quite a lot of freedom as a corporate startups. So we have a yearly budget, and we have a great commitment and a target. But we have, as a startup, actually, we are operating like a small company within a big company. We can use the benefits, we can use, for example, the corporate services like IT, like legal, like HR, and so on. But all in all, we look at the figures once per year. Yeah.
Okay, very good.
And it looks good.
Arno, I remember the last year we always talked about evaluation criteria. We talked about founders, the idea, the application, remember all that. And now we are getting into the phase, if I interpret it correctly, where we're talking about like more profit orientated. So, and sometimes you meet the startups at a very early stage. So how do you evaluate that? How does it shift it into that direction? And how can you evaluate at a very early stage?
Oh, it's extremely difficult. Evaluating the promises or the substance behind the promises of a founder team is the hardest task, because you need to spend a lot of time with the individuals and find out what their thinking is, right? That's why we always ask for a financial model and a business plan, not necessarily because we believe the numbers that they are providing us, but it's just to understand the entrepreneur's way of thinking, how they structure their world and how they want to approach these challenges. And yeah, I mean that over time it has changed a lot, and especially in the past 3 years, we also have changed how we evaluate the business, and we dig extremely deep into the very concrete numbers and projects. And we have, for example, very intense customer reference calls with the startup founders. We ask a founder team, introduce me to your 3 largest customers or project partners, and then we have an hour-long call with every single one to just find out how concrete is the business potential behind this idea, how realistic is the estimation of the founders in terms of contract volume and contract timing. And once we completely understand the side beyond the founders, the market side, then we can go deeper into the interaction with the founders. And this has become much more important, especially in the past couple of years, because we've seen so much extremely unrealistic over-promising. And I think in the last 2 years alone, $2 billion of venture capital money have evaporated.
Yeah. Funny enough that you said evaporated, because I can remember it seemed there's an endless source of this money. You know, Roman, what do you say? I mean, from my point of view, we are coming out of a phase where money didn't matter at all. You want money? Oh, it's a great idea. Here's the money. So how do you see that from a research perspective?
Yeah, when I look at that, and I'm pretty much mirroring what Arno was saying, like we've seen this first big wave of capital coming in with all the spec deals, 2 billions coming into an industry with a lot of promises, with a lot of investors who were promised amazing returns. And then we've seen that the industry has not really been able to deliver on these promises. So I think a lot of trust was gone. And then we've seen the firms that got a lot of money, that has driven sort of a first wave of mergers and acquisition, because there were slack resources. So if you have a lot of money and there's something, you're going to spend the money. And this has driven a lot of the first wave of what I call it, driven by the specs. And then when sort of the second trend came, which is not behavioral, which is more of a macro trend, when money got more expensive, this has led to firms needing to show that they're profitable, that they cannot have a burn rate that is as high, and that there's not an unlimited supply of money. And this has led then to firms divesting, firms needing to find a safe harbor. So this is sort of a very different level of M&A that we're seeing, or consolidation that we're seeing in the industry. So I'm seeing these two waves, and one has led to behavior, and the other one is macro, that has sort of led to a crisis and more of a consolidation that we're seeing now, and very different drivers behind these waves of M&A. And what Hans was saying, now we're seeing more that are actually exiting the industry because they're not getting bought. I think this is the same effect that we're seeing as a ripple down effect right now happening.
So there was the hype cycle. So if you have this garden curve, there was the hype cycle. There was 0 interest rates, and no AI. So the hype was 3D printing, and now we are in a completely other stage of the industry.
But Hans, that's a good one. So if we look at today's mergers and acquisitions, they're currently happening. Just recently, we had a few bigger ones.
Carbon 60 million. So
yeah,
still
as an example. So is it more, I mean, especially after what Roman says, is it more about strategy or survival? What is the dominating one? What do you see? Because a few of them are really, let's say, fleeing into a merger, or is it more like really strategic?
It's a mixture, I would say. One, they would have a kind of portfolio, though, that are safe for the futures, and the others, they really look on the figures, I would say.
Yeah. So you mentioned a few. So what are really the last recent M&As where you say these really describe the situation as an example? What would you say?
Well, I think, for example, Stratasys is buying a lot of different things, because they want to make sure that they have the right IP. And there are really different reasonings behind it. So
yeah, but this brings me probably to Sophie again. So I mean, if I would be Bosch Innovation, so there are different reasons why I have this incubator, right? So what do you see most? Is it most like Bosch is interested in integrating, or let's say have a spin-off, so selling it at a certain point, or let's stay then independent? What is the major dominating, or has it changed over time?
It's almost an insider questions. I start
if
from
you're allowed
Bosch.
to say.
I think Bosch's mission is invented for life. So it's really to provide technology for improved human life globally, with the technology and both beneficial. So Bosch Business Innovation serves this mission, and as I would say, independent entities to selecting, to identify, and also to scale the ideas, innovations to the business, but also to industrialization. So if I answer this question, I would say directly and shortly, I would say it depends on the technology. If this technology or ideas, for example, core business or core technology from Bosch, which is IP and so on, that would be a build business. So, but Bosch changes also the strategy. So that means we have a lot of innovative technologies from Bosch, but we are also trying to get, for example, external investors or partners to share the risk, for example, first reason, but most important is to build a venture together with, for example, venture methodology and so on. So all in all, the question is there's no black and white. It depends on the technology and ideas.
And on the opportunity, whether
exactly.
Yeah, very good.
Exactly.
Arno, we just heard money is not that easy to get nowadays. I mean, you should know best. Yeah, let's put it that way. So, I mean, I can imagine we have seen a lot of startups during the pitch next, and I imagine putting myself into their position, you need a much stronger proposition. And what do you say? I mean, let's do at least one more look into the startup area. What separates the one that make it from the ones that don't right now?
Well, of course, the very classic answer is always the team. Though the founder team that has a great chemistry and can go through thick and thin together is much more likely to succeed. But when you look at the business itself, there's still a big difference between companies and teams that have actually found a real solution to a problem that really exists. And there are teams still today who pitch to us that have found a solution for a problem that does not yet exist. And they are looking for the problem to solve just because they have a great technological invention. And of course, it's improving day by day, but we come from times where founder teams had developed a great technology and they were asking us for the application to their technology, how they could make business. So that's not how it works. And
that's basically a good pitch, right?
Fantastic pitch. And these are typically the let's say less experienced student teams, right? That have a great idea because they can analyze markets and they have great strategy tools to come up with some potential idea for a business, and they somehow have to validate the market. But what of course I prefer is the more experienced teams, like industry veterans that have decided to spin off a company because they have identified a real problem and they know that they can develop the solution for that. Yeah. And that's the ones that we are looking for and that we are trying to enforce.
Roman, finding specific problems in an industry to solve often leads to, let's say, get into the whole process chain. And this is what we see a little bit in M&As as well. So is that a trend that we see companies that say, okay, I'm nowadays building hardware, I invest in material as well, I invest in post-processing in order to supply the whole chain? Or is that something that we see?
I think it's something that we should be seeing more, going from just having a technological solution and being fascinated with the technology. As Arno was saying, like if you deliver a solution, you can sell something. You have identified a need of your customer, and they don't want probably just one aspect of the whole chain. They want to know how this fits into what they are doing, what they're potentially delivering to their customer. So I think for firms to build an entire solution and be properly integrated into what their customers are doing will be essential. So I think this is an important step, and I think this is something where we need to move on from just looking at the technology to also understanding the business model of the customers to see where we can add value, where we can integrate. And this might require firms to become a lot more niche rather than having like a one solution that fits all approach because they're technology fascinated.
I think this is a kind of verticalization what we will see in the industry now. If you look maybe on the shoe sole things, what Farsoon is doing and all the others, you get more verticalization. And I think although the M&A will follow this trend, so that you build up a kind of vertical pillars in the industry. So we will see a change of the structure of the industry.
May I elaborate on that? Because I think this is a very important point that Hans is making here. We see a lot of mixed shops here in this industry. Companies selling 4 different kinds of technology, 5 different kinds of technology, sometimes cannibalizing technologies, fighting for exactly the same application. And that is not extremely efficient because also there are not too many synergies between these technologies. And with the focus on applications, this game is changing. We see a lot of verticalization actually. Our transaction that we did last year with Cubicure sold to Align is exactly the perfect examples for this, because it was one applications company that has completely occupied that niche and is now buying technology that helps them to strengthen their position in exactly that extremely sharply defined market. So, and this is happening more and more, that the roll-up, the so-called roll-up games right now that are private equity funded are targeting exactly the occupation of one single very high margin niche. That's exactly the strategy that is extremely successful right now. And because it's very affordable to buy. We have a buyer's market, not a seller's market. So you can buy companies and modules to a supply chain at very, very low prices and build an extremely high valuable offering in a niche.
Sophie, you want
to I agree with you, Arnold. I think focus on application, this is one of the important parts to grow the technology from niche general technology to really industrialization. We actually, this is already part of our strategic thinking. So we focused on, as I mentioned at the beginning, different market segments. For example, semiconductor manufacturing industry or medical devices or energies. And the focus is very important because the requirements from our experience of different segments are totally different from different verticals. For example, the precise requirement from the semiconductor industry or the biocompatibility from medical devices and so on, or the high temperature requirement from the energy industry. So this focus also on the specific expertise from team, which you mentioned. Only if you consult the customer with the right solutions, with the really customized solutions, and you can get also the product from customers. So that's why we are not only providing the manufacturer services, but we start already from the design phase with customers. So we help customer, for example, to reimagine to use the AM technology instead for replacing also traditional technology. So this is the way, but I also not totally agree. This will totally change. We talked to a lot of customers. This was at the beginning also our fear. If our customer will buy some printers and they will do it by them in-house, they will focus on medical devices, for example. The feedback from customers, they say, no, they would like to understand the technology, but they will not have it in-house because they are not experts for that.
But Roman, I fully understand the thing. We're going more vertical, fully understandable. But if we see like big hardware suppliers that are buying now more and more from the supply chain, okay, if they should concentrate on one or two verticals, are they not limiting their possibilities? I mean, this is sorry. Let me add one more comment. So I remember the last 10 years, like everybody, we're talking about the AM industry, and I always heard some critical voices that said that this is not an industry. This is a technology delivering into vertical industries. So I mean, now we are talking about focusing on verticals, but is it limiting the companies that are inside the industry?
I don't think you have to see it as limiting. It's more like picking a niche and being really good at one of these niches and really delivering in this point. And this also makes M&A easier. So coming back to the point that I started with, making strategic acquisitions rather than opportunistic acquisitions. If I know there's a technology out there and I can buy the IP for that technology just to have it, it doesn't really help me in delivering to a customer or being more specific in what I can offer. So I think going for a niche enables companies or will enable companies to be more precise in what they offer, more clear in what they offer. Maybe they can pick one or two niches, but I think this will really help enable them to have a clearer offering. And the data also or empirical data also shows that the more strategic you are, the more value you can deliver, and the more opportunistic you are in what you buy, the harder it is to integrate it and bring it into a common solution. Imagine like if I'm the CEO and I'm buying something because the technology is there and I give it to my middle management, so now you integrate this into something. they're going to struggle. But if I'm saying, okay, what do you need to develop a solution for your customer? And then I can go looking around what I can get them to fit into that niche. This will be much more helpful for them. And they can then explore opportunities to maybe branch out from that niche, but at least there will be a clearer picture. And this is what the evidence shows when we run big studies, not just in the additive manufacturing industry, but in general in M&A studies. So I think this will actually help a lot of firms to have a clearer focus and have a clearer value proposition.
Hans, one question for you in this regard. So if we see now the current M&A landscape, what is happening in recent times, like desktop metal, for example,
Yes.
so we see that. So let's talk a little bit about what makes it successful or not, because Roman just mentioned not being opportunistic, rather being strategic. So if you consider those that just happened, what was the driver for them?
Well, I think it's twofold. You said at the beginning it's painful or it's healthy.
Yeah.
So let's say healthy is, for example, Voxeljet and X1. They are going now together. They are under the same holding, and suddenly it comes together what should be together. On the other side, there was a lot of burnt money in this desktop metal thing. Well, there is just this solution. There is a dead end, and that's it.
Yeah.
So it's a trade-off between healthy and painful.
Yeah. One thing that was really interesting me, and I wanted to ask you that. So, I mean, if we look at nature, there's a lion eating all the smaller animals. So we have, let's call it a food chain, yeah? So if we look into M&A from that perspective, don't get sorry for that, yeah? So let's say, who is buying who? That would be interesting for me as well. So there are bigger and smaller players, but looking at the supply chain, they are more at the end of the supply chain. I'm thinking about, for example, Dimension, which is like post-processing, but they are buying companies. So from whom is the initiative starting? Is there any like scheme recognizable? Arno, what would you say? Or is it like random, somebody that is already successful, has a good strategy, as Roman said, and I said, I'm going into that direction?
To be very blunt, from my perspective, in the last 2 years, most of the transactions that we've seen were not very intelligent. They were extremely opportunistic because the companies were available for very little money.
Yeah.
And that is never a good idea because a transaction, an acquisition of a company needs a lot of attention and it slows a company down. So you should only do it if it makes a lot of sense, right? And I did not see many transactions in the last 2 years that made as much sense as a lion buying Cubicure. It was a perfect match. And it was already pre-designed many years in advance. I'm now seeing some transactions that make a lot of sense, but they are not triggered from within the industry. I mean, let's face it, the big guys who are normally the buyers of companies in our industry, they don't have enough money. They are doing very poorly themselves or have done in the past years. They simply have not made enough money to really go on a shopping spree and expand their portfolio or their depth. I think this industry will be sorted out from buyers from the outside. People like what we've seen recently, SBO from Austria. It's a company that is dominating their market of oil field equipment. They have decided to enter also the technological field of additive manufacturing by acquiring 3T, integrated it into their company, and they could be ready for more acquisitions and very well set. And that's a company that has the balance sheet and the pocket money to do some really clever acquisitions. I don't see such clever transactions happening within this industry yet. I'm hopeful that it will happen in the future, but we still have a little bit of a way to go there.
Yeah, I mean, Roman, this would at least, pushing a little bit even more into the vertical direction, because the verticals then decide what to do, right?
Yeah, I think that's one way of doing it. I think what we're seeing now, it might become more clear because these companies actually know what they're after. They know what value they can get from additive and where they can place it. So I think in terms of M&A, what we would be then seeing is a lot more strategic M&A because they would have a clearer picture of what they would need in their value chain and how they could deliver that by making strategic acquisitions along their supply chain and thinking about the end product first. So I think this would make the mergers and acquisitions that we're seeing turn that into a whole different angle and different experience, that different level of strategy involved, I believe.
Sophie, so sorry, Han, let me ask one question that belongs to that one. So if we're talking about, let's say, the vertical that buys a specific company, like yours, for example, yeah? So what about then the integration? This would be a crucial part. And I can imagine two aspects, okay? So first of all, you are probably integrating a startup-size business from the perspective of the vertical. And I think most of our companies in our industry might be considered as a startup size for a company from outside, probably. Yeah? And the second one is there's a new technology being integrated, which probably either replaces or add to some of the traditional technology. How difficult is that integration? What would you say, Sophie?
I would say integration, it's not just combining a balance sheet and putting two companies together. I would say integration starts from my point of view already from day one of selecting the right partners. If the partners, both parties share the same purpose, the same value, and same vision and strategy, which is very important. Second is if, for example, the integration or to selecting a partner who can really expand my technology capability to provide customer more value. And the third one, I think, is a combination of the team culture, which is, from my point of view, very important. If the company's culture fits together, it makes the integration also easier. I would say that the integration is not, taking your example, it's not a big fish absorbing the small fish. It's from my point of view, it's to put the new species in this new company. It's make the ecosystem more resilient.
Yeah.
And this can be done very healthy. It's like I would say like marriage. If you fall in love, it's very easy to have the idea to merge, but it's hard work, to make it to navigate in the messy reality, right? Compromise and building and. To have shared future together, so this is a long-term work together.
Sorry, Sophie. This is basically just for you in the audience. This is basically the best metaphoric panel we had so far in the Formnext history. Thank you for that. So we had the line and marriage, and this is very close by. So talking about integration, what I'm heading for was basically you have a person thinking AM. Okay, and then you have a person that thinking traditionally. And I remember the last few years, that was quite a topic because first thing we needed to do is to teach the people to think AM and probably a little bit the other way around. So Hans, I mean, if you see this development, how difficult is it then? Let's say you are this AM company and a company is buying you because of your technology. And first thing the company might need to do is to teach the bigger company, you bought me, but you have to first think AM. Is that happening?
Well, I think that the company needs also a kind of freedom to develop. If I think now about Trumpf sold all the AMN business to Dubac. And now this new company, Adlix, has a lot of more freedom than under the brand of Trumpf. Now they have much more defense business, and the business is really growing. So you also need a kind of freedom to develop your business.
Yeah,
it is quite interesting.
So probably we use the last minutes more on money, if that's possible, and probably we bring up a third metaphoric pillar. No, I'm kidding, Roman. So if we see current M&A activities, because one of the questions we wanted to answer in this panel, how is that a potential indicator for the future progress of additive manufacturing? if you look at it on a research and personal, however you like, basis, how do you see the current activities and how that reflects what we can expect in the coming years?
So I think that after sort of this valley that we've gone through after the hype, that we're seeing some more activity that is, which I think is good, but we're seeing more structured activity, more strategic activity. Not saying there are some deals out there where I'm like questioning myself. I think there was one deal that went through with a valuation of 2 billion or something where somebody picked up 290 million. I'm like, this reminds me of what we saw 2020, 2021. So I think, yeah, it's a bit of a mixed picture. I see that we're seeing development. Also, I'm hopeful that we're not going to see the same thing again that we saw sort of in the last 5 years in terms of the hype and then the downfall. But I think we need to be more careful. I think also investors are more careful. They have learned what they need to look for. They have a clearer picture. So I think there is a lot more clarity. So I'm quite hopeful in moving forward. And I think once we see more of this verticalization, we're going to see different kinds of players entering the industry. And it'll be interesting to see what their experience is and if this model actually works out well, if we're seeing this model take over in other verticals, or if we see other mixed approaches, like how they work together. So I think it'll be very interesting.
Arno first, maybe.
I'd like to add a perspective, because we see a lot of trends in this direction. I think the current situation is creating. No, I have to start differently. The hype, right? So as an investor, you have to find the extremely fine line between overfunding a company and underfunding a company. Overfunding, we've seen a lot of overfunding for certain companies in the past couple of years. Overfunding creates a lot of stupid ideas. You become extremely inefficient with deploying capital because you don't think, you just try, and most of the ideas go up in flames. And what this creates is extremely fat companies, organizations that have very useless organs in all kinds of directions, and that fat needs to be trimmed, right? And it costs a lot of money. So hundreds of millions are being burned, and then you have to, at some point, you're reaching a point where you have to trim all the fat, and you end up with a very lean structure, but no one wants to fund it because the cap table and the shareholding structure is completely messed up. On the other hand, underfunding a company leads to a situation where they might not maximize on harvesting the potential once the situation picks up. But you end up with a very lean structure. And this is the companies that we are seeing right now. Those who make it, or who have made it to here almost already, or who get through the crisis in a healthy way with a, let's say, with a sort of functioning, well-structured cap table, will be extremely resilient companies who, if we can then fund them properly, will be able to scale very quickly, because these are lean organizations that have learned to survive and have managed to focus on their core competence, and they developed a very valuable selling proposition. And therefore, I'm convinced that the situation right now, as painful as it is, and I still have the suspicion that some companies don't die fast enough. There's still a lot of desperation or some remaining conviction that leads to the situation that some companies who should have been gone a long time ago are still there. But I think the situation right now is going to create extremely resilient, very, very strong companies. And we see the economy picking back up and customers coming back. So I think there are pretty good times ahead for the companies who have survived until here.
I think the tipping point in the AM industry is a very important thing. The hearing aid industry in the US was transformed into 3D printing within 500 days. And in Germany, we say domino effect. And there are a lot of tipping point effects in the industry. And I think in the near future, we will have a lot of more tipping points, that the industry will be stabilizing. and we will see more very interesting applications who have a good economy of scale.
So that means let's do a final round. Take Formnext as an indicator. It can be red, yellow, or green. Okay. So considering all that we've said about, and let's believe in the post-hype. Let's believe in that. Yeah. So if we get now a shift to more being profitable, so then the logical consequence, at least from my point of view, would be that we see a flourishing Formnext the next couple of years. Because if all of them are more focusing on profitable business, we see larger scale AM application, we see in real industrial implications. Is that something we can expect? Everybody probably a short estimations of these.
I would say I see green. Dark green in these directions. I think the consolidation is a very good positive sign of maturity of this industry. I think if you look at another technology, every innovative technology go to this cycle. So the consolidation, I think this is not this is not negative from my point of view. It's a part to make the AM, I would say, technology to industrialization and to a more resilient and also the scalable technology. So this will help also companies put their capability together and to really also convince the customer to adapt and to apply this technology. So I see this very positive.
I like that. Roman, first, let me give you a second task to the question. Sorry for that. Yeah. Considering figures, will we see then in the future, also considering the M&A activities, more bigger, more powerful companies, more profitable, market-dominating companies, or will the consolidation end in a much smaller market with only the lean guys surviving?
Good.
Sorry for that.
Oh, yeah, just drill me a bit more.
You are from a university.
Yeah. I'll come up with an answer. I think I'm not as green light as Sophie. I think we need to go, or the industry needs to go some more trimming and some more developments until we come out on the other end. And yeah, I'm not sure what we will look like on the other end, if it will be still an industry or if Additive will just be integrated into other industry conferences, for example. So I think we probably see more lean firms that are more specialized on the other end. But I think it will take a while for this development to take place. I don't think we can rapidly switch like this from hype to drought to...
I believe it too, but I mean, we have seen in other industries that exactly that could happen, that the next hype is just behind the corner.
I'm an academic. Yeah. I need to be somewhere in the middle.
Yeah,
I don't think...
That's a good one. Hans,
I think that the Formnext will be more verticalized from my point of view in the next 2 or 3 years. So we maybe will get a special section on shoe industry with using AM and special fields, or maybe AM in defense. This is also a very growing segment, so maybe we also have a very big area here with defense. So more verticalization here at Formnext.
I know. And this could turn out an investment tip. No, what is your perspective? Sure. I think Formnext as an indicator. Yeah.
When we look around at the show as it's happening this year, it's smaller than in previous years.
Yes.
The booths are smaller, the halls are wider, but this is not a reflection of the state of the industry now. It's a reflection of the state of the industry when the budgets for Formnext were made, which is about a year ago. And therefore, I'm convinced that next year's Formnext will look different again, because a marketing budget is the result of previous year's performance. And the year's performance is the result of the previous year's sales pipeline. And I've just gotten out of the Q3 reporting cycle with 16 portfolio companies from 6 different countries on 3 different continents. And I can say the mood has changed in the last 4 months significantly. it's not only about the Lego announcement and the Apple announcement and what's happening in defense. There are so many other applications in the making and gigantic projects in the making, which are going to lead to gigantic orders in the next 2 quarters to come. So I'm convinced that the performance that is now only disclosed to the investors, to the shareholders, and to the, by the management teams is going to result in completely different budgets in the next year. So therefore, we are right now in an orange phase right now, but everyone has the foot on the gas and is just waiting for the lights to turn green.
I mean, that was the third metaphor we used. This, thank you for that. So this made it the most successful metaphoric panel in Formnext. Thank you so much, ladies and gents. Again, it was fantastic having you. It was a real pleasure, and I hope you see it as well. So it's your round of applause to say thank you to the panelists here from my side as well. Thank you so much. Yeah, ladies and gentlemen, I tell you what, we have something special prepared for you. So this is the time to stay another 4.5 minutes of excellent Formnext highlights and stay here with us, be back on stage in around 5 minutes because there's something happening that you definitely don't want to miss. So stay tuned, see you in a few minutes. Thank you so much. Guys, excellent.
Do it like that. Do it like that. Do it like.
Come on!
Come on. Move it over. I said, baby, I know you're on a roll. Sweet honey, let's take it real soon. You know we got what you need, baby. So take it real long.
So welcome back, ladies and gentlemen, here at the industry stage at Formnext 2025, end of day one. And usually we would do now our after work talk, but I can tell you now, today, there's something a little bit different. It's funny for me because it's the first time I cannot even tell you what is going to be happening, but I tell you it's absolutely exclusively happening here at Formnext, here at our industry stage. And so before I tell you what's going to be happening, I let that do the companies that are doing that, and the moment deserves to be presented by them themselves. So let's go straight to the person who will reveal the news for today's first day at Formnext 2025. And please give a warm welcome and a warm round of applause to the president of Shinto Kogyo, Mr. Atsushi Nagai. Good to have you.
Hello, everybody. I'm from Munich.
Looks awesome.
Actually, my name is Atsushi Nagai, and I come from Japan, and I work for the Shinto Kogyo Japan. And today, I would like to special announcement that we want to create a future with Bosch company together. Next one. So this one, sorry. And actually, as you can see that with a very good opportunities, I could work with a Bosch company and to create a future together. That is the biggest announcement for my life. By the way, does anybody knows what Shinto means? Probably nobody knows. So that's why I will explain a little bit about our company, Shinto. Shinto means like, Shin means a Chinese character is new. To means east. So like a rising sun. We are going to challenge something new all the time. So that is symbolized this red color. And also these 5 fins and the 5 fins, like 10 fins here. So this symbolizes a shaking hand with the customers or partners. So means we are going to challenge and we are going to work together partners. So that this Shinto means. So rising sun. This is mountain for the Mount Fuji. But that's symbolize Japan. But this is what Shinto is. Okay. And our company is founded in 1934. Originally, our founder at that time worked together with the Toyota Group and could create casting machines to make castings. But this son, Mr. Kiichiro Toyota, created a Toyota Automotive Company. At that time, we developed the molding machines and to making an engine block for him. That's our starting time. And since then, we expand the business with the foundry and with a lot of sand. So sand handlings. And also, if the sand, you can clean the surface because the sand is sticking on the casting surface. So we remove the sand. And then also, if the sand environment is not so good sometimes. So that is why we have a dust collector business. So those business we expanded. Then, and actually using casting technologies, we started getting into the ceramic business. Is about 30 years ago. So that's, we can explain the ceramic business later, but our business expanded based on foundry technologies to other global, other different industries. And then, since then, we are 92 years old company, and we have 30 different, 24 different countries and 60 companies in outside Japan. And everything relating to the foundries and surface treatments. So that's, we are now here. And so that's our business. Our total employees about 5,000. So that's our company. Now, we try to, because the economy has been changing so much. So that's why we try to restructuring our business also. We don't call foundry anymore, we call form creations. And not we talk about the surface treatment, surface creations. And the material creations. So that's why based on 3 creations, we have IoT technologies, environment technologies, energies inspection technologies, that we're supporting all this process. So that's the way we try to restructuring the business at this moment. So in this context, form creation used to be, we create so much shape by using irons, aluminum. But now we get into ceramics, maybe some other materials or even waste materials to create something. So that's the way we try to expand the form creation business. Then this Bosch Advanced Ceramics business just very much fit into these areas. So that's the reason why it's very important for me to announce this special events. Next. Our ceramic business is 1993, we creating some media to clean the surface. About 2000, we creating some forming machines. First LCD liquid crystal display assembly machine was supplied by us to the shop at that time. Then, using these foundry technologies, at that time we're using a lot of big plates, like in the middle of the lady there, we can making big ceramic plates. And this ceramic plate can turn into the straightness measurement devices for the machine tool companies. So we can make 3 meters, 4 meters long range of the ceramic beams. So that's measuring the straightness of the machine tool head. So that business there. Then using these technologies, we can providing XY stage for some panels or some other related business. So that is we are there, but because we are only doing the big parts of ceramics only, so that is why we try to be together with a 3D Ceram Shinto, which we exhibited the second of this hall. then we can use a small ceramic parts by using a 3D printers to capable to make a small parts. So that is 2018. Through this 3D printer specializing for ceramics, then I start working together with a Bosch. At that time, kindly, they select our machine to work for their productions. So that's the starting time of our relationship with Bosch. And since then, we're talking about, at that time, oh, Bosch, that's very nice. We like to work together. But it was very tough time to work at because the quality is very tough. So, but our people in the 3D SRAM made it happen. So that's why we could supply the machines. But that's the starting point from Bosch. Since then, we have a very good special opportunities to be together with the Bosch Advanced Ceramics for further development. So this is today's announcements. Sorry. As together, from complex small size to high pressure large ceramics that we can provide, and we'd like to aiming for some niche market for the globally. And after this being together, is not only Europe and not only Japan. We'd like to change our ceramic business name to the Shinto Advanced Ceramics Japan. And Bosch Advanced Ceramics change names to Shinto Advanced Ceramics Europe. And we plan to set up Shinto Advanced Ceramics USA. So by doing this, at the beginning, with this entity, we like to work together global market. So that is our announcement, and I very much looking forward to working together for further development. Thank you very much for your listening, and thank you very much joining our special occasion promotions. Thank you very much.
Thank you very much, Mr. Nagai, ladies and gentlemen. Big applause for you. And I hope I didn't promise too much. So from a panel about mergers and acquisition, we getting witness of one of the biggest mergers and most important mergers in the recent time. So Bosch Ceramics is joining Shinto. Very good presentation. And now let's hear the other perspective, and let's ask the one that is on the other side. Please welcome with me Georg Stellmann, who is, CCO, that's correct, right,
yeah.
Georg? From Bosch Business Innovation. Please, Georg, stage is yours.
Yeah, thank you very much. I'm really excited to talk a little bit about Bosch Business Innovations, which I represent, and also, of course, about the star of the show, and that is Advanced Ceramics. Today, Bosch Advanced Ceramics, tomorrow, Shinto Advanced Ceramics. So first about Bosch. So we have the motto, invented for life, and that shows that technology is really at the heart of our company. If you look at the numbers, the 90 billion revenue we had last year was reinvested almost 10% into R&D. We are number one at the European Patent Office. And that is really the two things that are in our heart. One is to serve the customers, to improve their life, but with the technology that we create. Our business sectors are mobility, industrial technology, consumer goods, and energy and building technology. And you can see always there is some know-how and technology involved. And that's why at Bosch Business Innovations, we leverage this technology to create businesses beyond the core what Bosch is doing today. And Advanced Ceramics is one of these businesses. We are doing it across the globe. And now I would like to take you on a little journey in the history of Bosch Advanced Ceramics. And when I first met Yoshimoto-san from Shinto, he said something to me that impressed me quite. He said, at Shinto, we never give up. And I really liked that he said that, because if you look at the history, We also did not give up a long time. We brought advanced ceramics to a point where it's really ready to take off in the right hands. And I believe that Sinto is this place. And two important things that happened were Sophie Berninger came into Bosch Advanced Ceramics as CEO, and she took very wise strategic decisions. So our business was 90% injection molding, ceramic injection molding. And she said, we are good in this market, but it's not growing fast enough. And also she said, we are not the strongest in this market. So let's cut this part of the business and really focus on where we are the best and where the market is growing strongly. And so I really take my hat off to her for this decision. And you can see here that the business has growing nicely over the last 2 or 3 years. And now we are at another important milestone where advanced ceramics will become part of Sinto. And I believe that this is a great decision because for Sinto, ceramics is really at the heart of their strategy. And that's why I believe that they can take the business to the next level. And so I'm really proud about this. And now I'm really, really excited to announce also that Sophie will step down as the CEO because her job has been done tremendously. And as I said, technology is at the heart of our company. Nikolai Sauer, the CEO, will take over this role from January onwards. But now, really to the most exciting part of today, we will sign our partnership, our agreement live here on stage in the coming minutes. Thank you very much.
Jörg Schermann, meine Damen und Herren.
Thank you.
Thank you, Jörg. So while everything is being prepared for the signing, I would like to invite the two people just been mentioned in order to get a little bit deeper into the story of Bosch Advanced Ceramics and what brought us here. So please welcome me on stage, Mrs. Sophie Berninger, the outgoing CEO of Bosch Advanced Ceramics, and on the other hand, Mr. Nikolai Sauer, the incoming CEO of Bosch Advanced Ceramics. Good to have you here. Big applause, ladies and gentlemen. So, Sophie, you have led this company through an impressive transformation. I was really glad to hear that. Well, it was a really nice compliment. Thank you so much for that. And now you're handing the baton over to Nikolai. So can you take us back for a moment, like describe what were the most important steps that made this journey possible?
Well, thank you. It's an emotional moment also for me. Thank you for giving me this opportunity to reflect shortly. I would like to summarize as, former consultant, always in 3 points. First one is, I would say, there was important also right move, strategic move to focus on global growing market segment to achieve really also market visibility for the company. Second one is, which I would like to emphasize here, is really empowering the team. And most of the team members are today also here. I think that we could build a high performance team, which are not only putting team members together, but they are entrepreneurs. So they take extra mile, as I mentioned, and they take challenges and responsibilities, even for this move from out of Bosch to a new company. So this is the second. The third one is to look to select the right partner. So we actually, as a team, we selected Sinto as our happy home for the team member. And I remember one day I talked to Nagai-san in the evening in Japan. I told him this opportunity. He was so excited. He said, "Oh, this is really good opportunity." And we get in the deep talking and deeper exchanging. We figured out that we share the same purpose in Japanese, the nakama, which he showed in the last slide. This is important for successful M&A and integration.
Very good, very good. And as we are here in this closed surrounding, nobody's watching us, let me ask you on a personal note, what made you confident that Nikolai is the right person to lead the next chapter? So this is like the assessment.
I did already many assessments for him.
Okay.
So I can, Nikolai is a totally absolutely right person for this position. And Nikolai is, because he's truly passionate for the ceramic AM technology, and he believes truly on the growth of this business. And this first. The second one is he is the really center of the team. He is the team confidant of the. So this makes me very confident. He is the right person for this position, and BAC is in the right hand.
Awesome. What a transition, right, Nikolai? I mean, this is like, thank you so much for that. But leading to you, Nikolai, I mean, as I heard before, you started as an intern. I mean, this is a really crazy story. Now you will take over as CEO. How does it feel to step into this role at such an important moment? I mean, Sinto is taking over. I mean, how big could it be? And then getting CEO, what does it mean for you?
Well, it's a very honoring moment for me to have that possibility to have seen the team growing from the start on, having a technology which we just started as prototyping technology, and now we reached that point where we have several projects already running in serious production. And Bosch Business Innovations gave us that possibility to grow that business to that point. And together with Sinto, we will now have the possibility to get to the next level of our business. So that's something I'm really looking forward to, and I'm very, very honored.
And I was so glad, Mr. Nagai, it was a perfect introduction into the company and the all surrounding. And you mentioned already some of the opportunities, but the question to you, Nikolai, so what are the most exciting opportunities from your point of view in this new chapter together with Sinto?
Well, I just mentioned that we just started with several projects in serious production, and we have so much more in the pipeline, so much more customers really understanding the benefits of the technology, especially in ceramics. Additive manufacturing opens up just so much more possibilities, and to really earn the fruits of what we just started to work on. That's something I'm really happy to do in the future, and to do that together with Sinto.
And I hope not only you, but the whole team is excited.
Of course, yes.
Is the team here? So
yes, they're all here.
Can we hear the team just quickly once? There we are. Mr. Nagai, you see that they are quite motivated. Thank you for that. So thank you, two of us. Best of luck for you in the future, Sophie. Best of luck, whatever you're going to do in the future. Hope to see you soon. Back again. It's a pleasure. A lot of success for you and the new partnership. That is a pleasure having you. Because now I would like, thank you so much, and you can stay with me just a second, and then we do a quick exchange. Now I would like to invite the signing representatives to the table. So from Sinto, we have Mr. Tuji Nagai. Mr. Nagai, it's a pleasure to have you here, the president of Sinto. Big applause, ladies and gentlemen. And then we have Mr. Takeshi Hirayama, managing director of Sinto Europe. Big applause, ladies and gentlemen. And then from Bosch, we have Mr. Axel Dennis, CEO, Bosch Business Innovation. Axel, good to have you. Great to see you. And again, Georg Stellmann, CCO, Bosch Business Innovation. Georg, good to have you. So we leave you with a signing, and we step aside. Thank you so much for being here.
Great. Great. Now,
Another page?
yes, one more page. This is only for
this only.
Just for you in the live stream. This is a real signing. It's not fake. Indeed, they are doing it.
No, this is
only here.
Yeah. This is for the rent of the. Yes. Yeah. Exactly. Great.
So, Georg, Axel, Mr. Geheim, Sarah, all fine, all set?
Yep. Yes.
Looks good. Thank you so much. Big applause, ladies and gentlemen.
Thank you.
It has been done.
Thank you.
Thank you so much. So,
Yes.
dear audience, dear visitors at home at the live stream, thank you so much for being here, joining us at this fantastic moment. For you at the screens, I say goodbye for today. Let's make it a wrap. It was a fantastic first day at Formnext. Tomorrow you will see a lot of inspiring things here on industry stage. We're talking about AI. We're taking a step more into the future of additive manufacturing here at Formnext on industry stage. Looking forward to see you tomorrow again. See you and have a great evening so far.
Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. Cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special. Something specific. Specific industries.
Aviation aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
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 That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning,
Now watch me step. The weak was murder. I'm gonna get rid of the stress.